What is the silence that stretches between a thought and a distant star? If one could hold that silence in the palm of a hand, it would have the weight of time and the obvious cold of emptiness. It would feel less like an absence and more like a presence, a vast, patient thing that presses outward in all directions, indifferent to the fragile calculations of living minds. This question sits at the beginning of the account, as a single image that refuses easy consolation. The night sky is not merely a backdrop, it is a ledger of distances, a record of delay, and an architecture of separations that shapes the fate of all things that might call themselves alive. To speak of the cosmos is to confront numbers that resist intuition. It is not merely large, it exceeds the human capacity to grasp. There are, by conservative estimates, on the order of 100 billion to 1 trillion galaxies within the observable universe. Each of these galaxies hosts hundreds of billions of stars. When the tally is taken, when the mind attempts to count, it arrives at figures that make the handfuls of sand on a beach look petty. The familiar phrase that there are more stars than grains of sand on all of Earth's shores is not idle rhetoric. It is an attempt to translate cosmic immensity into a tactile metaphor. Yet even metaphors fail halfway, because there is more than scale at stake. There is also the profound loneliness that the scale enforces. Light is an old traveler. What reaches an eye or a telescope has already been on a journey of years, decades, centuries, or longer. The light from some stars began its course before humanity had a name for fire. The light from many more began while continents were still finding their place, while oceans were young, while life itself was only experimenting with complexity. A stellar photon that brushes a sensor today may have left a star when the face of Earth was utterly unrecognizable. That is not merely a poetic fact, it is a constraint. The cosmos is a museum of bygone moments. There is an inherent lag between cause and observation, and the lag grows as the square of distance grows harder to fathom. Between 2 points of light lies not only vacuum but a topology of difficulty, radiation hazards, the sparse matter that is not merely barren but inert, to biological flourishing, the yawning timescales required to bridge distances at subluminal speeds. For a would-be voyager, the universe imposes a set of invisible prisons, barriers that are not bars or walls, but rules of physics that convert possibility into improbability. These are the prisons of speed, radiation, and dissipation. They make travel provisional and communication a conversation with ghosts. Humanity's mathematics reach to the horizon of these limits. The nearest star beyond the sun sits more than 4 light-years away. That distance is already inhospitable to the everyday ways that living things move and flourish. A message sent at the speed of light to that neighbor would be a conversation that spans nearly a decade for a simple exchange. Cross the gulf to another system, to another galaxy, and the waits expand to millennia. The expansion of space itself compounds the isolation. Where once distant galaxies drifted slowly in a gravitational ballet, their recession speeds now accelerate. Over unimaginably long intervals, the once visible clusters of galaxies will become islands to themselves, their light red-shifted away, their companionship muted. The cosmos is, over deep time, sculpting its own solitude. That solitude has emotional consequences when it is allowed to enter the human imagination. In quiet rooms beneath dark instruments and in field stations where radio dishes whisper, people convene with a smallness that is not merely physical, but existential. This is not to anthropomorphize the universe. It is to describe a human response, an overwhelming sense of being brief and brittle in a theater of extreme duration. The feeling is twin-edged. On one side lies awe, an almost narcotic sense of being part of something grand. On the other lies an anxious vertigo. If the cosmos is so immense and indifferent, what are the stakes of any life, any culture, any testimony? The Earth is the only known place in the universe that currently replies. Its life has been an experiment in persistence and transformation. From the vantage of deep time, human history is an afterthought, a sudden punctuation near the very end of a long, slow page. If the history of Earth were compressed into a single day, complex life would begin in the evening hours. Modern humans would appear in the last seconds before midnight. Recorded history would occupy milliseconds. Against this chronology, even the loudest human acts, cities, monuments, technological revolutions, are ephemeral scratches on a surface subject to erosion on grand scales. Wind and water work with patient cruelty. Mountains rise only to be ground down. Coastlines shift, continents drift, surfaces subduct. This geological mobility has a fierce implication for the memory of things. The planet does not hoard its past indefinitely. Rocks are recycled in the belly of the planet. Landscapes that once held human cities will, across a span of hundreds of millions of years, be folded into the deep interior or worn into ash and dust. The memory of civilization, if it is encoded only in transient structures on the surface, is perilously fragile. This is a technical claim with philosophical weight. If the physical record of human activity erodes, then the cosmos, despite its immensity, punishes ephemeral presence with erasure. Yet the universe can be both archivist and destroyer. The sky keeps records in the most patient form, light and cosmic background noise. Microwave photons from the early universe whisper of epochs before atoms cooled enough to form molecules. Spectral lines betray. The composition of ancient stars, the flicker of distant quasars, catalogues the births and deaths of forged elements. These are archival traces of large-scale processes, not of gardens and poems. For the traces of something like civilization to persist for eons, they must be written in durable ways, in isotopic anomalies, in global-scale geochemical signatures, in objects cast into deep space beyond the reach of terrestrial geology. But such durable markers are rare and easily masked by later processes. It is here that the idea of an invisible prison becomes doubled. Space isolates, but time erases. A message cast into the void is not only delayed, it is at risk of being unreadable by future eyes. In the same way, a civilization that aspires to leave a permanent mark must contend not only with the distances that separate stars, but with the geological, climatic, and stellar processes that wear away inscriptions. The cosmic stage rewards those who can engineer permanence on a scale beyond the familiar human lifespans, but perfection is elusive. Even dense, hardy artifacts may be buried, oxidized, shattered by micrometeorites, or diluted into the background noise of the cosmic substrate. From this vantage, the number of stars, this overwhelming multitude, becomes an unfriendly statistic. If every star hosted life that grew in complexity, cultivated knowledge, and then succumbed to the grinding forces of time, the cosmos would be a museum of the absent. The light would be a testimony to vanished minds. Yet the observation of bright stars did not reveal whether intelligence ever flickered on their worlds. The visible universe is simultaneously full and empty, full in raw potential, empty in confirmed companionship. This paradox feeds a particular kind of anxiety and a persistent fascination. Humanity looks outward, compelled by the question of whether it is alone, and is forced, by the very nature of the cosmos, to wait for an answer and to wonder whether any intended messages have been lost to the slow attrition of time and the distortions of distance. The mechanics of isolation go beyond mere distance. Space is not a neutral field in which messages can drift unharmed. Cosmic rays buffet surfaces and mutate complex molecules. Interstellar dust abrades and occludes. Stellar flares can sterilize planetary surfaces in an instant. The interstellar medium is an understated adversary. Regions dense with star formation are also noisy and hazardous, while the quieter interstellar voids are poor in the raw materials necessary for life as known on Earth. In this way, the cosmos designs niches that are hostile or hospitable, and those niches are scattered and rare. For any intelligence, the path to long-term persistence is to navigate not only the emptiness of distances, but the hostility of the medium itself. There is a further, more subtle prison, informational decay. Signals sent across vast distances are degraded by scattering, absorption, and Doppler shifts. The clean tones one might imagine for a message, a deliberate beacon. A simple sequence of prime numbers, perhaps, do not survive intact across cosmological spans. Frequencies shift, cosmic background processes create noise. The very passage of light stretches it into oblivion if the source is receding. An attempt to converse with the deep past, to ask a distant civilization whether it still endures, becomes a conversation in which both voices are altered by the medium and by time's relentless stretching. Human cognition responds to this cosmic architecture by crafting narratives of urgency and of endurance. There is an instinct to send out flares of meaning, to launch probes, to inscribe pages into durable materials, to encode messages into isotopic anomalies or into gravitationally bound artifacts placed beyond planetary recycling. Equally, there is an impulse to look inward and to understand how fragile any outward-facing enterprise is. The psychological landscape is complex, hope and futility entwined. The desire to be seen counterbalanced by the plausible futility of being remembered. Documentary voices across disciplines repeat a central motif. The same laws that permit stars to form and planets to cool also conspire to keep spaces between them largely unbreachable for fragile organisms. Gravity shapes galaxies and traps gas into stars. Nuclear fusion powers suns, but relativity sets an absolute speed limit that makes cosmic neighborhoods remote. Thermodynamic gradients allow life to extract order from environments, but they also ensure eventual decay. In this manner, the universe is neither hostile by design nor benign. It simply operates according to principles indifferent to wishes. From a human perspective, that indifference can approximate cruelty. From the cosmos's frame, it is the grammar of existence. Yet the story implicit in the scales and the separations is not only one of desolation. It is also an invitation to humility and a revaluation of significance. If the cosmos is an ocean of islands, then the islands themselves, planets capable of nurturing complexity, become precious. Their rarity magnifies the value of what they contain. The fact that humanity's records are ephemeral is a prompt to ask whether significance might be measured less by permanence across geologic epochs and more by the depth of mind's engagement with the brief moments. The night sky, vast and indifferent, reframes human acts as fragments of a larger song. Each act of knowledge, of cultural production, of ethical decision becomes amplified in the mind precisely because it is finite. There is, finally, an aesthetic truth that emerges. The vastness of the universe fosters a peculiar intimacy. When confronted with immeasurable distances and the slow erasures of time, humans have developed ways of connecting to the cosmos that are intimate rather than expansive. The observations collected with patient instruments, the careful cataloging of spectra, the quiet choreography of radio arrays scanning the silence, these endeavors are acts of listening rather than of conquest. They are efforts to bear witness to the cosmos's record and to place humanity's brief narrative into a larger frame. That listening is a moral stance as well as a methodological one. It accepts the universe's limits and chooses to lean into the work of understanding, of remembering, and of making meaning within the narrow corridors available. Thus, the opening tableau of this long investigation is not a vista of triumphant exploration, but a profound question about limits. How does a species that experiences time on the scale of decades learn to operate when the cosmos answers at the tempo of millennia and eons? How does one communicate across the invisible prisons of distance, radiation, and time? And what does it mean to leave a mark in a place where erosion, plate tectonics, and cosmic violence conspire to reduce monuments to sediment? These questions do not have simple answers, and they are not idle. They set the terms for every subsequent inquiry into Earth's deep history, into the possibility of earlier intelligences erased by geological processes, and into the strategies that a species might adopt to be legible to a future that will likely be very different. The universe's vastness is both canvas and constraint. To regard it only as a canvas is to ignore the prison-like features that enforce solitude. To regard it only as a prison is to overlook the persistent tenderness of observation and scientific patience. In the next part of the account, the narrator will trace the consequences of these separations closer to home, the way time and erosion conspire to erase traces, the subtle signatures that might survive, and the strategies by which intelligences, if they ever existed before the present, could have made the cosmos remember them. For now, the opening image remains, a silence heavy with distance, a sky scattered with lanterns that are both messages and fossils, and an insistence that the universe's immensity compels not despair, but a careful and humble form of inquiry. What would it mean, in practical and moral terms, to build a vessel that never lets its occupants forget the feel of Earth's gravity? Imagine a craft that, from the instant its engines ignite, presses a soft, constant weight against the feet of those within, a perpetual dawn of 1G, while it relentlessly carves velocity out of the void. That image is not merely technical fantasy, it is a hinge concept. A ship capable of continuous one-ig acceleration, protected from the worst of radiation and the steady grind of micrometeoroids, changes the scale of possibility. It does not abolish the distances of the cosmos, but it alters the experience of them. It reorders time for those aboard, rearranges the list of feasible targets, and, crucially for any species fearful of being erased by geology and erosion, provides a practical channel for sending durable testimony away from a planet that will not keep memory for free. The assumption is precise and heavy with consequences. 1G is not an arbitrary comfort. It is the familiar metric of life lived under a world's mass. It keeps muscles from atrophying in the same rhythm to which bones and hearts evolved. For a civilization planning voyages measured in decades or centuries, continuous 1G offers a way to avoid the physiological and ethical complexity of engineered bodies, suspended animation, or long multi-generational governance. It promises a ship where bodies age in a manner congruent with home, where clocks tick relatively straightforwardly for the crew, But to grant such a promise, engineers must reconcile a suite of unforgiving problems: energy, collisions, radiation, heat, and the logistics of human-scale sustainability stretched across lonely light years. The most immediate physical consequence of sustained acceleration is speed. Under 1g, a craft accelerates as a person feels the same push as standing on Earth. Over months and years, this results in speeds that approach the cosmic speed limit. In non-technical terms, the difference is dramatic. The ship does not skim uncomfortably near the speed of light like a feather. It asymptotically approaches it, meaning that from the perspective of those aboard, relativistic effects, time dilation, increased mass energy requirements become unavoidable companions. The very equations that make near-light travel possible also raise paradoxes of experience. A traveler under continuous 1G could, in principle, cross interstellar distances measured in tens of thousands of light years within human lifetimes as measured on board, yet return to a home that has aged far more. Time becomes a corridor with sliding glass walls. The closer one draws to the speed limit, the greater the difference between ship time and the time left behind. That mathematical door opens ethically challenging vistas. A civilization that can accelerate continuously at 1G can, in an absolute sense, outrun geological erasure for certain kinds of evidence. Artifacts or data placed beyond the reach of terrestrial recycling, laced into interstellar probes, embedded in the hull of craft that range outward orbits of comets, or launched into stable orbits around the sun but far enough to resist plate tectonics, stand a better chance of surviving. Millions to billions of years. The ship becomes a custodian of memory. Its very existence offers a new strategy for making a fleeting culture legible to a future observer or to a different intelligence scrolling through the galaxy's archaeological palimpsest. But the same ship also embodies a new kind of solitude. To seed memory beyond Earth is to accept that those who seed it and their home may become unreachable in practical terms. Preservation carries the cost of distance and the tension of deferred meaning. An archive cast into the dark might outlive the bloodline that made it, but it may also remain unread by any audience that can reconstruct the context. So what does it take to make that vessel real? The energy ledger is the first cold account. Accelerating a mass continuously at 1G requires prodigious power, and the kinetic energy rises steeply as velocity increases. The conceivable engineering approaches split into families, each with trade-offs that anchor speculative thinking to the constraints of physics. One approach is to carry propellant and a reaction mass of extraordinary specific impulse. Fusion propulsion, if harnessed cleanly and efficiently, offers a plausible path, dense energy, high exhaust velocity, and a fuel supply that in principle could be compact enough for long missions. Antimatter promises even more compact energy density but encounters formidable production and storage challenges. Beamed propulsion, where energy is supplied externally from a planetary system through powerful laser arrays that push light. Sails shifts the burden away from the ship but requires an infrastructure of planetary scale and commits the craft to trajectories tied to the beam's direction and lifetime. Then there are speculative ideas like interstellar ramjets, which collect and use the interstellar medium as reaction mass. Elegant in concept, they falter against the thinness of space and the engineering complexity of scooping plasma at relativistic speeds. Yet energy is only a part of the ledger. The chosen propulsion determines the hazard profile. At high fractions of light speed, even a single grain of dust becomes an instrument of catastrophic erosion. The interstellar medium is not benign vacuum in the engineering sense. It is a medium carrying ions, neutral atoms, and dust traveling relative to the craft that will become bathed in kinetic fury. A micron particle colliding with a craft at relativistic speeds deposits enormous energy into a tiny locus, punching holes, ablating structures, and generating showers of secondary radiation. Thus, collision shielding is not mere armor, it is a strategy of staged defenses. Thick physical shields, multi-layered Whipple designs, can fragment incoming particles and spread the energy of impacts. But they come with mass penalties. Active defenses, magnetic or plasma shields, may curve charged particles away, but neutral atoms and macroscopic debris are not so easily steered. Precursor probes or directed lasers might be used to sweep and clear a path ahead of a large craft, vaporizing or deflecting hazardous objects years in advance. The implication is systemic. A 1-1 craft demands not only advanced engines but logistical choreography across light-year scales, scouting, clearing, and maintaining lanes through a medium that is indifferent to any single journey. Radiation is another persistent adversary. At relativistic speeds, the flux of cosmic rays and high-energy particles on the forward aspect of a ship increases. Particles, that would otherwise be sparse in the interstellar medium are transformed by relative motion into a headwind of ionizing bombardment. Even if the hull itself is robust, secondary radiation produced by particle interactions with shielding materials can flood the interior. Solutions range from thick mass shielding, which increases weight, to electromagnetic fields that deflect charged components, to active countermeasures that detect and neutralize incoming radiation via cascades of engineered interactions. Each solution trades simplicity for complexity and mass for survivability. The design becomes a negotiation between the mass budget, the tolerance of living tissues, and the long-term integrity of electronics and records meant to outlive continental drift. Heat dissipation is often the invisible constraint in these accounts. A high-power reactor or engine will generate waste heat that must be radiated away. In deep space, radiators are the only outlet. At high speeds, the craft itself also collects kinetic heat from the interstellar medium and from the friction of rarefied gas and dust hitting the bow. Radiator surfaces become massive, and their geometry and emissivity define mission limits. In practice, the need to throw heat into a cold background sets a ceiling on sustainable power. A one-cruise regime therefore demands not only energy generation, but an honest accounting for thermal management, radiators, coolant loops, and materials able to operate over decades or centuries without catastrophic degradation. Amid these engineering accounts, the cultural and epistemic implications pile up. A continuous one-egg ship reframes what a civilization chooses to value. If survival and memory are priorities, then the investment into these vessels is not merely technological but civic. Entire societies would need to coordinate resources, labor, and political will to build, launch, and support missions whose returns may be measured far beyond the lifetimes of contemporary institutions. The decision to carve memory into a craft that leaves home is also a decision about whom or what the civilization trusts to stand as witness. Will the testimony be a small, curated archive, encoded languages, images, and genomic blueprints, or will it be structures, engineered artifacts designed to endure micrometeorite bombardment, cosmic rays, and the eventual slow pummeling of time? The 1G ship enlarges the palette of options, but it does not resolve the deep question of whether permanence is worth the cost of separation. There is, too, a quieter psychological contour to be acknowledged. The daily life within such a craft will be defined by strange normality, a steady gravitational pull, the hum of engines, the view of stars transformed into a gradient of blues and elongated streaks as Doppler shift colors and aberrations rearrange the sky. For the human psyche, or for any cognitive system designed to find meaning in patterns, there is solace and familiarity. 1G sustains a rhythm of labor, sleep, and sociality that echoes planetary life. That echo may be crucial for sustaining the cultural practices, storytelling, ritual, education, that preserve a civilization's internal coherence across the months and years of transit. The ship thus functions as a cultural vessel as much as a physical one, a moving archive of customs, ethics, and memory, sustained by architecture that mirrors an ancestral environment. Yet establishing such habits does not eliminate existential friction. A species that dispatches a one-egg vessel must confront the reality that arrival and interpretation are separate problems. Reaching a distant planet or deposit of interstellar material is one achievement, ensuring that the record left there will be read meaningfully by some future intelligence, be it biological, digital, or geological, is another. The cosmos does not aid the translation. Spectra shift, languages rot, contexts vanish. Durable inscriptions must be intentionally self-explanatory, embedded with redundancy and with modes of interpretation that do not presuppose continuity of culture. That challenges precisely the kind of deep-time design problem that archaeology, semiotics, and materials science can address in collaboration, but it remains stubbornly difficult. The 1-6 ship may deliver the message physically, but making it legible across epochs is a separate project of extraordinary subtlety. Finally, there is a limit imposed by cosmology itself. Continuous acceleration mitigates some problems of distance, but cannot make light speed a non-factor. Even accelerated travel cannot beat c. It can, however, exploit relativistic effects to shorten subjective time. That leads to scenarios where those who depart and those who remain experience time differently, sometimes profoundly so. In the perspective of deep time, the galaxy itself is not static. Stellar neighborhoods rearrange on million-year scales. Galaxies recede under cosmic expansion on trillion-year horizons. A civilization that seeds memories beyond its planet may create legacies that outlast its planetary cradle, but it also accepts that the web of potential contact, the possibility of reciprocal exchange diminishes with each additional light year. In this way, the one egg craft is both key and object lesson. Key, because it reduces the tyranny of acceleration and makes long voyages biologically feasible. Lesson, because it exposes the remaining constraints that are not engineering problems but existential ones. It is a technology that can preserve, at a cost, a fragment of a culture. It is not, however, a magic eraser of the universe's indifference. The theft of memory by erosion and plate tectonics can be countered by judicious deposition beyond a planet's churn, but the broader loneliness enforced by distance and time remains. The ship alters the terms of the conversation between a species and the cosmos. The conversation becomes one of deliberate, distributed testimony rather than immediate fellowship. If there is an emblem for the argument, it is not a rocket blazing triumphantly across the sky, but a slower, quieter image. A needle stitching a single thread through an immense dark fabric. Each stitch, each ship, launched under 1G, binds a sliver of temporal continuity into a universe that otherwise erases with patient economy. The stitches are small against the scale of galaxies, but they are not meaningless. They are artifacts of desire, the desire to matter, to be legible, to outlast the geological shock that erases footprints. They are, perhaps, the kindest possible response to the cosmic question that began this account. Faced with silence and distance, a species can either equivocate in isolated terrestrial expression or commit resources to sending its voice into the long night, in hopes that elsewhere and elsewhen the voice may be read as testimony rather than as a fossilized accident. In the end, to imagine such a ship is to perform an ethics of scale. The one's assumption organizes priorities, who endures, what is preserved, and how the marks of a brief civilization might be made to cross the twin prisons of space and time. It is a thought experiment that resists simple optimism. It reveals logistical immensities and moral complexities while offering a practical avenue beyond the immediate erosions of a planet. It promises a way to reach out into the deep registry of time and to place there, deliberately, evidence that life once reflected upon itself. That promise reframes silence not as an accusation, but as a space to attempt something both brave and humble, to send a carefully built witness into the darkness, to accept that the witness may speak to nobody known, and to hope that the act of casting memory outward is in itself a meaningful measure of significance in a universe that keeps its own ledger with indifferent patience. What does it feel like to unmoor civilization from its cradle and watch the familiar geometry of home dissolve in the space of a few breaths? That question anchors the moment of departure, not an act of breaking a tether, but a deliberate extraction of memory from a world that will, in time, forget. In this part of the account, the passage is not a film of characters and plot, but a chronicle of thresholds, the precise, frightening stages by which a single vessel cleaves itself from Earth's history and carries a curated fragment of meaning outward through a widening silence. The first threshold is intimate and absurdly close, the moon. Under continuous 1G, acceleration is not an event but a constant condition. The push becomes the anatomy of life itself. Within the hull, routines persist. Beds angle to the steady pull. Hands learn the geometry of buttons and controls by feel. In a sense that is profoundly practical, leaving under 1G preserves continuity. The mind and the body are given familiar scaffolding in an unfamiliar undertaking. That scaffolding is also a kind of anesthesia against panic. It is easier to sing a remembered song, fold a shirt, or brew a ritual cup of something warm when the muscles behave as they always have. Outside the portholes, the moon is at first a coin of light, close enough that instrument panels still show telemetry as a steady stream. The lunar surface is suddenly reduced to pattern, Maria and highlands detached from their terrestrial context, a geography divorced from the human scale of cities and roads. From a few 100,000 kilometers away, the moon is no longer a place one might walk to within a winter afternoon. It is a compacted topography, an island of shadows. As the craft accelerates, the moon thins into a crescent, then a bright sliver, and finally a white spill on the starfield. The optical experience is simple and radical. A familiar object becomes a fossilized icon before the ship has even slipped beyond the Earth. Moon system. That slipping is a choreography of engineers' calculations and the quiet rituals of farewell enacted at a societal scale. Launch assets track and adjust. Ground controllers adjust beam pointing for telemetry. Data packets stream homeward with a latency that grows by the minute, then by the hour. The last images transmitted to the planet, a composite of the launch pad, of the slipping flame, of the Earth's limb, become a kind of secular reliquary. They are at once footage of departure and a designed artifact. chosen to be legible to a future archaeologist, a curated blend of color, geometry, and redundancy meant to endure, if not physically, then within the social record before the record snaps. Mars is the second larger threshold. In ordinary development, Mars sits as a destination in its own right, a second home, a testbed of off-world industry and improvisation. In this narrative, Mars is also an intermediate way station and a reminder of scale. The passage from the near moon to the distant red planet compresses much of the familiar space of the inner system. Under sustained acceleration, Mars ceases to be the months-away neighbor of baseline imaginings and becomes part of a telescoped corridor through which the craft moves with steady inevitability. The red disk grows, swells, then shrinks as the ship sweeps past in a relativistic ballet where time, for the voyagers, stretches and shrinks with velocity and distance. The planet's familiar features, the lowlands, the dust, stippled deserts, the polar caps, are rearticulated into vivid, abstract signals on the ship's instruments, temperature gradients, spectral scans, dust density. Each reading is both practical and symbolic. The ship reports back specimens of the inner system's ecology of rubble and plasma, microplasts of asteroid fragments, solar wind pressure, the thin hiss of ionized particles. Between these thresholds there is a sustained technical drama that rarely intrudes into popular imagination. The management of a headwind that becomes a storm as velocity rises. At even modest fractions of light speed, the interplanetary medium stops being a pleasant vacuum and becomes a hazardous sea. Tiny grains of dust, sub-millimeter flecks of rock, carry energies that scale with velocity. What had been a cosmetic pocking in the era of chemical rockets becomes, at these velocities, a source of cascading damage. The craft's frontal shields are designed to exchange mass for time, sacrificial layers that ablate, fracture, and sprawl in carefully modeled patterns so that the living spaces remain intact behind them. The shield's erosion is itself a kind of slow, visible timekeeping. Designers watch its patterns like mariners of old watched barometers. The rate of erosion informs both the sense of risk and the arithmetic of reserve mass. There is also, running alongside the mechanical imperative, a litany of small technological rituals. Precursor probes are dispatched to sweep a narrow lane for macroscopic debris. High-energy lasers, fed by beamed power or onboard reactors, operate in a silent choreography to vaporize or nudge away threatening fragments years, months, or days before the main ship arrives. Magnetic and plasma fields ride at the bow as a dynamic skin, bending charged particles into benign arcs and melting the edges of potential projectiles. Each of these measures is a scene of concentrated engineering, sensors, feedback loops, and passive systems working in the cold logic of survival. There is no drama of heroism in these operations. The drama is the sustained attentiveness of design to an indifferent medium. As the ship breaches the classical bounds of the inner system, conventional markers of distance, kilometers, and astronomical units become inadequate to feeling. The sun, once a daily dominator of mood and cycle, reduces in apparent size even as its radiative might remains. Relativistic aberration alters the way starlight is perceived. A forward-facing cone of light compresses the starfield, while the sides and rear of the craft grow dim. Doppler shifts begin to tint stars toward the blue in the forward direction, reddening the aft. This is not a special effects flourish. It is an index of speed itself. The cosmos rearranges its visual grammar to accommodate motion. Communications, the invisible tether between the ship and home, change in character. Early on, there is a conversational intimacy. Messages fly back and forth in near real time, questions met with answers and images, public rituals televised and captioned. Within days, hours, the one-way light time stretches. A message that once crossed the system in minutes grows to hours, later reaches days. The social fabric of those remaining and those departing begins to fray along this temporal axis. Decisions that would once be socially negotiated in weeks are now made in strategic isolation. This is less melodrama than a simple rearrangement of governance. The ship must operate with a mandate robust to long, unanswerable silences, designed with protocols that are not dependent on rapid feedback. In practical terms, autonomy is not an ideological posture, but an engineering necessity. There are also subtler psychological currents. Ice! The acceleration under 1G preserves the habit of walking, the sensation of weight underfoot, the normal rhythms of circadian activity under artificial lighting and controlled atmosphere. Yet the external cues that anchor time, the daily arc of sunrises, the weather, the cycles of seasons are removed. The result is a strange interior temporality. Clocks tick Instruments measure elapsed distance, but the everyday sense of belonging to a planetary diachronicity withers. Rituals are invented or adapted to replace these cues. Commemorative days are kept, names recited, songs sung. The social architecture aboard becomes a portable hearth. These practices are not quaint. They serve a functional purpose by maintaining cohesion across the monotony of long transit. Then comes the final threshold of the solar system, the heliopause, the conceptual and physical edge where the sun's solar wind yields to the interstellar medium. In classical imagination, this is a line one crosses, and then is simply in interstellar space. In practice, it is a gradient of interacting pressures, a multi-layered frontier of changing particle populations and shifting magnetic fields. To traverse it in weeks requires speeds that dwarf those of the early space age. At such speeds, the passage through the heliosphere takes on the air of a rite of passage. The sun's influence weakens, and with it, the last gentle traces of a planetary-scale ecology. For the occupants of the vessel, for the intended archive riding outward, the heliopause is an editorial choice as much as a navigational milestone. Beyond it, the ship is less likely to be subject to later solar system dynamics and the grinding, forgetfulness of plate tectonics. In sending testimony past this boundary, a civilization offers its record a better chance of surviving the slow digestive processes of a planet. Time dilation, which heretofore was a theoretical appendix to engineering, becomes a felt metric in these circumstances. For the observers left behind, the ship's outbound clock runs differently from that on board. The paradoxes here are philosophical as much as physical. A message sent from the ship toward home arrives desynchronized. A reply comes delayed, sometimes arriving to an environment that is reconfigured in ways large and small. When the voyage is measured in subjective months or years, the home system may have turned through weather cycles, political cycles, and even geological episodes. That dissonance becomes a narrative theme. How does one reconcile the ethics of leaving with the ethicality of memory? The outward-bound testimony may survive the geological churn, but its human context, the living communities that framed it, will likely have changed, fragmented, or dissolved. There is also the practical accounting of energy and heat, of mass expended in reaction mass, and of radiators that glow faintly against starlight. A ship accelerating at 1G cannot do so without paying the thermodynamic price. Onboard reactors, fusion or otherwise, produce vast waste heat that must be radiated away. Radiator panels extend like the wings of a silent insect, catching no sunlight but pushing entropy outward. The geometry of those panels, their vulnerability during micrometeoroid ablation, the maintenance schedules required to keep them functional across the trip, these are not glamorous problems, but they are the ones that quietly determine success or failure. In this sense, the voyage is less heroic conquest than an exercise in sustained maintenance, long repetitious checks, spares cannibalized for repairs, data-driven decision trees executed with the calm of technicians maintaining a large, fragile instrument. As the vessel recedes, it becomes an object of two simultaneous gazes, one from the planet-watching telescopes and arrays that measure trajectory and signal, and one from the craft itself, telescopes oriented aft to take precise, reverent images of Earth as it becomes a fleeting, fragile bead. The photographs and scans made in those last hours and days are both technical telemetry and cultural artifacts. They are designed to be redundant and robust, multiple formats, multiple material encodings, and deliberate encoding strategies that anticipate the loss of interpretive context. In the archive are pictorial arrays, spectral keys, mathematical priors, and seeded structures intended to be mechanically interpretable long after languages shift or die. The craft becomes a postal system for civilization's memory. When the solar system's boundaries fall behind within weeks, the outward progress is not merely a story of velocity, it is a narrative about rescaling what counts as permanence. A record placed into deep space may physically survive the churn that erases surface structures, but the act of sending it is itself a moral wager. It bets resources today on the value of testimony tomorrow, and on the possibility that an intelligence, human or otherwise, will find and decipher the deposit. In philosophical terms, it is an acknowledgement that the primary competitor to oblivion is not always brute duration, but intelligibility, the extent to which future eyes, in whatever mode they take, can reconstruct context from a deliberately designed set of clues. Finally, the image that lingers beyond the practicalities is a simple, discomforting one. A small vessel receding until it is an ordered point of light, then a smear, and then a phantom photon pulse lost in a sea of background. To the eye trained by instruments, it is a trajectory. To the human imagination, it is a line of intent. The voyage is a stitch made in a fabric vast beyond comprehension. It changes very little in the physics of the galaxy, but in the human ledger it is a decisive act, an attempt to translate the ephemeral into the durable, the local into the translocal. Leaving the solar system in weeks is thus an exercise in concentrated priorities. It requires technologies that push current knowledge, designs that reconcile mass and energy with survival, and cultural commitments to narratives that are not immediately reciprocated. It reframes the value of terrestrial things, an inscribed page, a curated seed bank, a recorded melody, all small against the scale of cosmic history, are placed in a context designed to protect them from the slow erasures of geology. To do so is to assert, in the simplest terms, that memory is worth the voyage. In the months and years that follow such a departure, the questions raised at the outset do not vanish. The silence of the night sky remains heavy with distance. The ledger of separations maintains its indifference. Yet the act of casting testimony outward is a kind of moral defiance, a measured, instrumented refusal to let the planet's living record be swallowed without a trace. The passage past the moon and Mars and then beyond the heliosphere is not a rupture alone, but a passage that transforms a civilization's relationship to its own temporality. It is an admission, modest and arbitrated by engineering, that some things are worth the cost of being remote, and that to speak into the void is sometimes the only practical way to outlast erosion and forgetfulness. What does it mean to aim at a neighbor whose light takes years to arrive and whose reply, if any, will come back, changed by the slow arithmetic of distance? Alpha Centauri is an answer to that question posed in the most minimal, stubborn fashion. It is near in cosmic terms and yet remote enough that the rules of time and motion begin to assert themselves with blunt clarity. At roughly 4.3 light-years, it is the first meaningful step outside the sun's comfortable jurisdiction, the place where the practicalities that have been, whispered about in equations and engineering documents, become palpable realities. It is the threshold where relativity stops being an abstraction and begins to shape choices about design, ethics, and the kinds of testimony a species might hope to leave behind. Alpha Centauri is not a single point, but a family of suns, a gravitational conversation of binaries, with Proxima slipping in on the margins, and that complexity matters. Aiming for this system is not merely lining up a site and burning fuel. It is a negotiation with a small, bright cluster of possibilities, a multi-star neighborhood offering different orbital dynamics, differing radiation environments, and varying prospects for stable, long-lived places to hide memory from geology. The very topology of the destination introduces strategy. Which star will carry the archives most safely? Which orbit will avoid the grinding work of planetary resurfacing? These are not hypothetical games. They are concrete choices that will determine whether a message survives tens of millions of years or is ground into indistinguishable detritus. There is a simple arithmetic that governs the mood of any mission to Alpha Centauri. Light takes more than 4 years to traverse the gulf. That single constraint reframes every human impulse. Conversation with home becomes prolonged and ceremonial. A greeting sent before the launch may arrive as a feint, folded thin years into the future, while replies to any decision made in the dark of interstellar transit may well be irrelevant. By the time they are received, the immediacy of feedback vanishes. Institutions that are built for weekly board meetings and rapid provisional policy cannot operate in the same way when the principal interlocutor is 4 light-years away. Operational autonomy is not a political posture. It is an inescapable engineering requirement. For the ship actively making the crossing, the experience is governed by 2 blended registers, subjective time aboard, and the objective ledger of the external universe. Under continuous one acceleration, the humane, muscle-preserving regime that has dominated this account so far, the traveler's clock compresses subjective experience into a handful of years. Under these conditions, Alpha Centauri is not an impossibly distant myth, but a reachable place within a human lifetime. That fact is intoxicating, yet it conceals a paradox. The faster the craft goes, the more pronounced the relativistic effects become. From the ship's perspective, the journey can be measured in a few short cycles of seasons, while back-home generations, institutions, and the slow machinations of geology continue at their own unaccelerated pace. The universe thereby imposes a temporal split. Departures and arrivals are measured in different calendars, stitched together only by delayed photons. Relativity is not merely a technical caveat, it reshapes narrative expectations. Arrival at Alpha Centauri cannot be treated as a single cinematic moment. It is a sequence of small, exacting acts, a long acceleration phase where engines push steadily to produce speed, a midpoint flip to begin braking, the slow, desperate choreography of deceleration as the target's gravity and stellar winds loom larger in instruments. Each of these acts consumes energy and decision margin. There is no deus ex machina. Slowing down demands as much work as speeding up, and carrying the mass to decelerate compounds the initial energy bill. Thus, mission planners face a fundamental trade: to carry what is needed for a soft arrival, or to accept a high-speed flyby that trades interpretive clarity at the destination for a lower immediate cost. The practicalities of arrival are defined by three stubborn adversaries. First, the interstellar medium. Even a sparse cloud of atoms, when met at a significant fraction of the speed of light, becomes a hostile wind. Micrometeoroids that would barely nick a chemical rocket are transformed into missiles. Shields and sacrificial layers become measures of survival. Every gram spent on protection is a gram subtracted from the payload. That contains the civilization's testimony. Second, radiation remains a constant hazard. High relative velocities increase the intensity of cosmic particles striking the bow of a craft, creating a forward-facing barrage that must be managed to protect both organic tissue and delicate archives. Third, thermal management is an unromantic but unforgiving concern. Power is necessary for acceleration, life support, and communication, but power must end somewhere as heat. In deep space, radiators are the only outlet. They unfurl like metallic lungs, vulnerable to impacts and erosion over the long haul. Those engineering dramas have ethical corollaries that are subtle and acute. The choice between a decelerating vessel that can linger in the Alpha Centauri system and a fast flyby that deposits small, autonomous probes is partly a question of priority. Is the highest aim to leave behind as durable a testament as possible, even if the witnesses will never return? Or is the aim to place instruments that gather knowledge about the new neighborhood and relay it back at the cost of not preserving a cultural archive in situ? Every pragmatic reply presupposes a moral assertion about what counts as success: the preservation of memory, the expansion of knowledge, or the ensuring of biological continuities. Those purposes are not exclusive, but they are in competition under the hard constraints of mass, energy, and time. Alpha Centauri also functions as an experimental crucible for strategies that attempt to solve the erosion problem articulated earlier. In a geological sense, planets are bad long-term safes. Tectonics, volcanism, and weather will, over into the millions and tens of millions of years, efface the footprints of a brief technological moment. So a civilization wishing to make its record endure must think in terms that outpace planetary recycling. The Alpha Centauri system offers several plausible shelters. Placing an archive into a wide, stable orbit around a low-activity star can minimize thermal and collisional cycling. Embedding records into the cores of small, inert bodies like comets or asteroids, objects that will not be churned under tectonic plates, buys additional durability. Depositing data into orbiting swarms of inert, radiation-hardened beacons multiplies the odds that at least one fragment will survive. Each option demands different trade-offs in initial mass, shielding, and interpretability. Interpretability itself is an often overlooked technical problem. An archive that survives physically may still be unreadable in principle. Languages rot, cultural priors vanish. To make testimony legible over geological epochs requires a kind of meta-engineering. Redundancy of encoding, self-rectifying keys, and physical structures that invite decoding. Mathematical sequences, physical constants, and universal atomic transitions are favored anchors because they do not presuppose cultural continuity. Yet even these must be paired with robust, non-volatile materials that resist sputtering and decay. The craft that voyages to Alpha Centauri therefore carries not only the weight of artifacts, but of epistemic design, a set of choices about how to make meaning endure in the absence of shared context. The act of choosing Alpha Centauri as the first target carries a cultural symbolism that is hard to understate. It is close enough that the technical achievement is believable. It is distant enough that the consequences will be felt as a test of patience and imagination. In the public imagination, the launch of an interstellar mission to Alpha Centauri is less a conquest than a ritual of outward casting, a deliberate attempt to say, "We were here, we thought, we hoped." We hoped. That ritual has to be reconciled with the practical knowledge that the reply caveat is real. Any handshake with a distant star will be, by definition, asynchronous. The civic rituals that support the mission must be built to outlast political quarterly cycles and to weather cultural vicissitudes. Arriving at Alpha Centauri, then, is as much a matter of governance and narrative as of propulsion. Who decides what to send? How are choices made about the cultural artifacts, the genomes, the knowledge to be preserved? Those choices are made collectively and irrevocably. Once a mass is committed to interstellar transit, retrieval is not an option. The mission becomes a moral ledger recorded in titanium and ceramic, radiators and inscriptions. The selection process encodes values that will outlast their authors, and that fact changes the way any such enterprise speaks about itself. It cannot be merely an expression of technological prowess. It becomes an ethical bet on the kinds of stories a species wants to tell into the long night. On approach, the arrival sequence reads like a study in patience and vigilance. Sensors sweep the destination system for dust densities and macroscopic debris. Precursor microprobes may have been launched years or decades earlier to map hazards and to seed deceleration means. Magnetic sails or plasma braking schemes, concepts designed to use the target star's own medium as a braking partner, come into play as practical ways to avoid the crippling mass penalty of carried propellant. The final kilometers are navigational poetry, small corrections, large decisions about where to place an archive, whether to settle a probe into a long-term orbit around a quiet dwarf or to risk a planetary surface for the sake of semantic resonance. Each choice alters the probability that the testimony will survive and be legible. The sensory metaphors that have suffused this account yield a particular image at Alpha Centauri, photons arriving as lagged letters, instruments interpreting ancient light as both a map and a set of instructions. The first photos returned from the system will be read with a mixture of scientific discipline and cultural hunger. A bright spectrum, a pattern of isotopes, a suspiciously regular structure in an orbiting ring. Each will be carefully weighed against a background noise of natural processes. If the mission finds evidence of past life or engineered signatures, the discovery will be filtered through the same humility that opened this account. Distance complicates narrative. Time erases context. The scientists and archivists on Earth will receive data years after the events they report, and their interpretations will necessarily be provisional. If no signs of intelligence are found, the mission will still be a kind of success in a broader register. The ability to place material beyond Earth's geological reach and to have it outlast planetary churn is itself an experiment in persistence. The deposits might be read by whatever intelligences slowly evolve there in the far future, or they might sit inert as a quiet fossil from a different evolutionary comedy. Either outcome reframes the human act from triumph to testimony, evidence that a thinking species once sought to be remembered. Alpha Centauri thus functions as a practical testbed for the strategies sketched across this account. It is the nearest laboratory in which the trade-offs between mass and shielding, between carrying propellant and using environmental braking, between leaving slow, richly encoded archives and fast, nimble probes can be adjudicated under real conditions. The system's modest distance means that the venture is expensive, but not categorically impossible, and that makes it uniquely useful. It forces questions into the open. What does a civilization owe to its future? What counts as a durable record? And how much of present life is it reasonable to commit to a task whose return is not guaranteed in a human time scale? In the end, choosing Alpha Centauri as the first interstellar aim is a decision that insists upon a particular form of humility. It recognizes that the universe will rarely meet human timing, that messages may be sent without immediate recipients, and that the best that can be offered is carefully engineered witness. The act of sending a vessel, whether one that lingers and becomes a silent archivist in a distant orbit, or a constellation of small probes that scatter meaning across the system, is an ethical declaration, a species choosing not to accept geological erasure as the final verdict on its existence. Alpha Centauri is the first decisive proof that the invisible prisons of distance and time can be addressed, imperfectly and expensively, with human ingenuity. Yet it is also the point where those prisons begin to show their seams. Relativity alters experience. Communication latency recasts governance. The interstellar medium punishes hubris with erosive patience. To aim at that star is to accept limitation and to translate longing into durable craft. It is, perhaps, the kindest possible experiment to stitch a thread into the dark and, by doing so, to insist that someone, sometime, might read it as an account of a brief, reflective species that chose to be remembered. What if the most stubborn obstacle between a civilization and its desire to be remembered was not only distance or erosion, but time itself? That thought that the clocks that mark a life aboard a ship do not march in step with the clocks left behind. On a planet, is a quiet, unsettling hinge in the moral geometry of any attempt to send testimony into deep time. In the arithmetic of relativity there is a simple, brutal truth. Motion changes time. The farther and faster one goes, the more the universe recounts the ages of different observers. This is not metaphor, it is a structural rule of the cosmos with immediate consequences for memory, responsibility, and the practice of leaving durable traces. Here, at the heart of that rule sits a single symbol, the Lorentz factor, usually written as pa. It is the translator between clocks, between the proper time measured by a wristwatch moving with a vessel, and the coordinate time measured by a clock that remains on Earth. The Lorentz factor is defined by a compact expression, tris1, sector 1, sector 2, sector 2. In words, it says that as an object's speed v approaches the speed of light c, the denominator shrinks and via grows without bound. The growth of duh is the growth of estrangement between two temporalities. If ca is 1.0, motion is negligibly slow and clocks remain synchronized. If ca is 2, one set of clocks runs half as fast as the other. If ca is 10, one experiences a decade while the other lives a century. This algebra has immediate, visceral implications when transported into the language of voyages and testimony. Consider a voyage whose subjective duration, the time experienced aboard, is 5 years. That number, comforting and human in scale, might have been chosen because it maps onto a lifetime of planning, training, and institutional patience. But what does 5 years on the ship mean for a planet left behind? The answer depends entirely on speed. If the craft travels at a modest fraction of light, say 0, c, is about 1.048. The ship's 3.5 years will translate into roughly 67 years of Earth time, a small discrepancy, socially manageable. The genealogies of families and institutions on the planet will advance by only a few seasons more than the traveler's view. But the calculus changes quickly. At 0.6c climbs to 1. 3.5 years aboard becomes roughly 4 years at home. At 0.78c, a velocity that is often quoted in thought experiments about human-scale interstellar travel is close to 1. Is close to 1. 6. In that case, a 3.5-year subjective voyage corresponds to roughly 6 years on Earth. The gap widens once velocities slip deeper into relativistic territory. 0.9c high rises to about 7 and the same 5 years aboard would be measured as nearly 25 years back home. At 0.999c is on the order of 22, making those 5 years equivalent to some 70-odd years on the planet. These numbers are not mere curiosities. They are the skeleton of choices. A civilization that seeks to stitch a thread into the dark must decide whether to prioritize minimizing the time that passes for the people or systems that carry the message, or minimizing the time that passes on the planet that nurtured it. Higher speeds compress subjective time, enabling a messenger to cross larger swaths of the galaxy within a single lifetime of those aboard. Yet in doing so, the mission increases the chronological distance from home. Families age, political orders dissolve, and the living communities that once consented to the project may not be present to witness or contextualize its meaning. There are two complementary ways to look at what relativity does to a journey. From the planet's frame, the ship is a slow external event stretched over years of light travel. From the ship's frame, the universe ahead is contracted, distances shortened by the same Lorentz factor that stretches clocks. That is, length contraction says that in the moving frame, the distance to a target D is perceived as d, ni. For a ship aiming at Alpha Centauri, which sits about 37 light-years away in the planet's coordinates, traveling at easel 1, 6 reduces that span to roughly 2.73 light-years in the ship's own coordinate measures. The practical outcome is striking. The same physical fact that renders the home clock older also makes the destination feel nearer to the traveler. In other words, relativity purchases subjective proximity at the cost of social synchronization. The deeper philosophical nettle appears when those arithmetic facts meet the ethical desire to preserve testimony over geological timescales. If the aim is to deposit an archive beyond a planet's cycle of plate tectonics and erosion, then safe placement beyond a star's heliosphere or into the orbit of a small inert body in a foreign system is an obvious tactic. Relativity offers a tool. By choosing higher velocities, a civilization can physically deliver testimony to distant neighborhoods within the lifetimes of its agents, ensuring the act of deposition is a decided, intentional event rather than a project passed across countless hands. But the cost is already clear. Those same missions will return to find their home altered in ways the mission builders cannot foresee. A message conserved in a distant orbit may outlast the political and cultural context that created it. It may, in practical terms, exist in a social vacuum. That is the asymmetric consequence of temporal compression. There is an accessible way to see the trade-off with a concrete example. Suppose planners wish a traveler's subjective time to be 5 years for a crossing to Alpha Centauri. Solving the relativistic relation yields a velocity around 0. 78C and POI 1.6. Earth will have aged about 6 years. It is not dramatic. The continuity of institutions and families might survive such a gap. But if planners demand a subjective crossing of, say, 1 year to the same destination, the required U increases, and with it, the earthly lapse grows larger. At extreme velocities, the ship's passengers return in a world in which decades or even centuries have passed. The mathematics of the Lorentz factor is indifferent to the concerns that feel humanly urgent. It only multiplies. There is another related structural shift that should be acknowledged because it is rarely the focus of sentimental narratives. About interstellar travel, the relativity of simultaneity. Events that are simultaneous in the planet's inertial frame are not simultaneous in a ship's. The consequence is that the decisions made in the ship's frame, where the archive is jettisoned into a distant orbit, the data etched into ceramics and isotopes, will map onto different sets of simultaneous events back home. The moral texture of consent, therefore, becomes complicated. Did the people who authorized the mission understand fully what the future would look like? If the mission's leadership is comprised of those who will not live to see political decisions on Earth that arise in response to success or failure, the notion of democratic oversight and temporal accountability begins to fray. The physics of time thus enforces a political question. How should responsibilities be allocated across different temporal perspectives? Relativity also reshuffles practical risks in less abstract ways. The forward Doppler effect amplifies the energy of incoming photons and particles in the ship's direction of travel. For a vessel traveling in substantial fractions of C, the cosmic microwave background and the ambient starlight ahead are blue E-shifted, climbing into bands that can be biologically and materially damaging. Similarly, neutral atoms and dust grains encountered at high relative speed deposit energy at a rate proportional to the square of velocity. Small particles suddenly act like high-caliber projectiles. Both radiation and collision hazards become more severe the faster the ship attempts to move. Thus, the same decision to embrace relativistic speeds in order to compress subjective time also multiplies the engineering costs of shielding and repair. Relativity helps with clock management, but increases the bill in mass and thermal management. The famous twin paradox is the simplified narrative skeleton that often gets pointed to for dramatic effect. One twin stays on Earth, the other journeys at high speed and returns younger. In richer documentary terms, the paradox foregrounds something subtler, asymmetry of worldviews. The traveler's archive, the one cast outward to escape the planet's geological digestion, is shaped under the temporality of the moving frame. It will be read, if and when it is read, by observers whose clocks and contexts are those of the systems the archive enters. If the archive was designed with assumptions held by a living civilization whose institutions decayed during the ship's transit, interpretive gaps may be profound. The twin paradox thus signals a kind of epistemic divorce. The builders of meaning and the eventual readers of that meaning may occupy different historical planes entirely. That epistemic divorce is not purely speculative. It forces practical design constraints on the archival materials themselves. If an archive is intended for the deep future, its encoding must be robust to the loss of shared symbolic systems. Mathematics, fundamental spectral lines, and physical constants are safer anchors than any contemporary language or iconography. But even these anchors presuppose an interpreter capable of abstract reconstruction. In a relativistic mission that compresses subjective time enormously, the depositors must double down on redundancy and universality, because the longer the light-time gap and the greater the relativistic separation, the less likely that a continuous cultural apprenticeship will exist to bridge the interpretive chasm. There is, moreover, a temporal irony in the kind of missions that relativity makes attractive. Much of the argument for sustained one acceleration and high cruising velocities is ethical. To avoid the physiological degradation of long voyages, to allow living minds to govern their acts coherently, and to preserve the moral agency of those who carry the testimony. Time dilation helps there too by shortening the subjective duration. It permits agents to make choices and to know the consequences in their lifetimes. Yet the same shortening severs immediate social ties and places the moral weight of the mission onto a generation that will carry its social memory into isolation. The ethics of choosing velocity is thus a tension between caring for the bodies and minds that undertake the mission and caring for the communities that remain as a home. Finally, the documentary imagination must consider what time dilation does to the narrative of meaning itself. A message deposited on a distant, long-lived object might survive tectonic churn and erosion for hundreds of millions of years, but survival is not the same as comprehension. To send something that merely survives is an act of preservation. To send something that can be interpreted across profound breaks in simultaneity is an act of translation and pedagogy across epochs. Relativity gives the sender a chance of placing objects beyond the reach of geology, but it cannot substitute for the interpretive labor required to make those objects speak. In the ledger of long projects, then, the Lorentz factor appears as both instrument and ethic. It is a way to trade subjective time against social continuity. It is a lever that allows a civilization to compress the experience of multi-light-year travel into a human S-scale horizon. But it is also a choice that deepens the solitude of the act and complicates the moral picture of consent, accountability, and meaning. The ships that exploit time dilation do something powerful. They change the shape of history for their makers. The makers who use these ships must decide whether the aim is to ensure that something of their civilization survives anywhere at all, irrespective of who will be there to say, "That was us," or whether the aim is to preserve continuity with future generations of the same species or of others who might, in the far ages, evolve the capacity to read the deposit. When the question is put in that register, relativity ceases to be an abstract sidebar and becomes central to the ethical calculus of any program that attempts to outlast geology. It frames the cost. Speed buys preservation against erosion, but taxes political continuity and interpretive context. It reframes the stakes. The longer the reach, the more careful the design must be to make the message legible across different rates of cosmological ledger airkeeping, and it reminds the species that writes into the sky of an old humility. Universe does not merely hold a silence. It counts time in multiple ledgers, and one must choose which ledger one is willing to have govern the fate of what one leaves behind. In the quiet arithmetic of the Lorentz factor, there is, finally, a moral image, a civilization standing before an accounting table, weighting the needs of bodies, the demands of memory, and the yearning to be known. To cross a few light years in 3.5 years of felt time may be possible with velocities that are within conceptual reach, but each increment of speed alters what the planet will have become upon return and what the archive will mean when found. Time dilation does not rescue memory from erosion by itself. It reorganizes where and when memory might be placed and whom it may speak to. It is a tool of preservation and also a reminder that the most difficult barriers to being remembered are not always mechanical. They are temporal, ethical, and interpretive, the very problems that make the act of speaking into the long night at once heroic and unbearably modest. What does it mean, at the edge of a first success, to choose not to stop? The question is not merely tactical, it is a moral fissure that opens across institutions, across generations, and across the interior lives of those who bear the responsibility of decision. Alpha Centauri had been framed as a test, a near neighbor, a place where the hard arithmetic of relativistic travel, shielding, and archival design could be turned into a lived experiment. Reaching it was supposed to answer a cluster of questions about feasibility, survivability, and legibility. But when the instruments had reported the system's quiet, and the deposit of testimony had been placed where plate tectonics and planetary churn were no longer the immediate predators, a harder option presented itself. The collective that had built the vessel, engineers, archivists, cosmologists, civic planners, and the anonymous labor of thousands who had never boarded, faced a choice: remain the first species to place a durable witness in a neighboring system, or continue far beyond the comfortable geometry of local stars into the wide, sparse intervals between the spiral arms. The deliberation unfolded like any major public act in a species that had learned to mediate risk through numbers, committees, and ritual. Reports aggregated not into dramatic pronouncements, but into layered documents, risk profiles, thermodynamic ledgers, socio-political scenario trees. The documents were read aloud in panels, their margins annotated with the slow indignities of compromise. Yet beneath the spreadsheets were other things that numbers could not entirely capture. The collective mood of a civilization whose self-image had pivoted from planetary to translocal. The private grief of those who had watched home grow dim through the aft windows. The small, tenacious hope The memory cast outward might one day intersect with something that could read it. There was a practical reason to consider going farther. The local neighborhood offers a kind of geological safety, but it does not eliminate long-term threats. Stars move, encounters happen on million-year timescales, and dense star-forming regions carry hazards that could eventually disrupt an otherwise safe archive. Moreover, the architecture of permanence is statistical. A single deposit in one system is fragile by number alone. Dispersal increases survival probability. From an information theoretic point of view, redundancy across gravitational wells and orbital architectures buys resilience. The argument was plain. Depositing many careful, well-designed archives across different nodes of the galaxy was a more effective hedge than concentrating resources on a single, prestigious location. Yet the jump from a neighbor to the spiral arm is not incremental, it is categorical. The sun sits in a minor spur of the Milky Way, the Orion spur itself a modest lane between larger, denser arms. To reach a different arm, to cross the interstellar cloud complexes and the voids between them, is to confront timescales and material risks at a scale that humbles planners. The distances involved expand by orders of magnitude. The interstellar medium becomes not a background but a landscape, clouds of dust and ionized gas that change drag, punctuate radiation environment, and alter the very strategies of propulsion and shielding. The move from cautious neighbor to ambitious dispersal demands rethinking the entire mission architecture. And with that rethinking came an acute ethical question. How much of present life should be spent to increase the chance that some trace of that life will be legible in epochs where the very concept of present has dissolved? The debates were not melodramatic. They were iterative and bureaucratic in the way that long projects tend to be. Committees that had once specialized in power plant design found themselves accounting for semiotic durability. Ethicists, conversant with climate policy, drafted frameworks for intergenerational consent. Archaeologists and semioticians sat with materials scientists to choose alloys and isotopic anchors that might survive cosmic weathering. The language shifted between frames, thermodynamic cost, interpretive redundancy, cultural representativeness, and, crucially, acceptable loneliness. Loneliness, in this context, had a texture. To elect to travel not to a neighbor but toward the Perseus arm or the Scutum Centaurus complex, toward dense regions where, perhaps, more small bodies might be available for long-term storage, where star formation could, paradoxically, offer both hazards and shelters, was to accept that reciprocity would be effectively impossible. A message might be placed on a cometary nucleus in a distant arm and survive the grinding hands of geological agents for hundreds of millions of years, but who, when, and if anyone would read it were questions that could not be satisfied by engineering alone. The decision to go was then a moral gesture, an exercise of hope against the arithmetic of solitude, a declaration that some stories are worth betting lifetimes on even if the audience is unknowable. On the ship itself, the decision manifested as a slow reorientation of purpose. Systems engineers recalculated delta-V budgets, fuel margins were shifted, and the relative value of carrying propellant versus relying on environmental braking schemes was revisited, where Alpha Centauri permitted deceleration methods that exploited local stellar winds and magnetic fields. A longer voyage required planners to think about staged braking across multiple encounters, perhaps using capture into minor bodies or magnetically assisted sails as intermediate anchors. The logistics multiplied. Precursor microprobes were reprogrammed to scout farther corridors, to map dust lanes, and to profile radiation fields months or years in advance of the main vessel's transit. Data that had once been local telemetry became part of an ongoing cartography of an expanding corridor through the galaxy. Density gradients of neutral hydrogen, particulate size distributions, localized turbulence in the interstellar medium, the spectra of diffuse ultraviolet background, all inputs to a navigation problem that was as much about avoiding attrition as about reaching coordinates. In the command centers left behind, the public rituals adapted to sustain collective assent. Museums curated special exhibitions about the mission's new aim. Children's school programs adopted the language of stitching memory into the galaxy as a civic duty. The cultural artifacts chosen for dispersal were debated in public fora, not merely a canon of music and images, but multi-layered packages that included mathematical primers, models of planet-forming processes, and, more controversially, ethically curated records of human conflict and failure as well as achievement. There was a deliberate temptation to sanitize history, to make the recorded record legible by emphasizing a curated, heroic narrative. But the collective decided repeatedly, and often against political pressures, that honesty would be a better long-term strategy. If the hope was that distant intelligences would reconstruct a species' story, those intelligences would require clues about how humans handled complexity, failure, adaptation, regret. The archives would thus contain both the luminous and the shameful. This was part of a broader ethical posture. Preservation should not be an attempt to advertise success, but to make an honest testimony of existence. Practical rituals accompanied these policy choices. The archives were encoded with extreme redundancy, multiple physical formats, isotopic markers to anchor timescales, and self-referential keys from physics to arithmetic to help reconstruct syntax without shared language. Materials were chosen for their corrosion resistance in vacuum and their stability under ionizing bombardment. Ceramics with high melting points, noble metal alloys, layered composites that could blunt micrometeoroid impacts. The packages were designed to be embeddable into the cores of small bodies, a ringed archive lodged in a dark comet, a lattice sealed into an asteroid's heart. The logic was simple and maddeningly intricate. Bury the record where planetary churn could not digest it, and surround it with quantities of mass and orientation that made it less probable the item would be stripped by stellar encounters. Engineers also anticipated the interpretive problem. A set of bootstrap instructions was devised, stepwise procedures that, starting from basic atomic constants, would enable a sufficiently intelligent reader to establish ratios, measure isotopic half-lives, and reconstruct a basic lexicon. These were not naive primitives. They were compact, layered pedagogies designed by cognitive scientists and mathematicians to be maximally informative under extreme uncertainty. The aim was not to guarantee comprehension, but to increase the probability that a coherent narrative could be reconstructed by an intelligence that might have different sensory modalities and different temporal priorities. The decision to go further reconfigured risk across scales. Locally, a longer mission meant reallocating scarce mass from ornament to shield, from novelty to redundancy. Globally, it meant accepting deferred meaning. The act of scattering archives across spiral arms is an investment in epochs rather than eras. It is a bet that the statistical improbability of any single packet surviving is overcome by number and distribution. It is a calculated refusal of the romantic notion that permanence requires a single inviolable vault. Instead, persistence becomes emergent, a distribution problem, a probabilistic portfolio of memory. Crossing the local interstellar cloud itself was a series of small, intense moments that had nothing of cinematic flourish and everything of meticulous attrition. Sensors measured the increasing density of fine dust and the subtle modulation in charged particle flux. Whipple shields designed to fragment and disperse energetic projectiles were monitored continuously. Active shielding schemes pulsed magnetic fields to deflect charged ions, while sacrificial layers ablated in predictable sequences. The ship's forward aspect became a thinly changing ledger, mass lost, micrometeoroid impacts catalogued, tiny surface pockmarks photographed for later analysis. The visible effect when observed from a distance was negligible. What mattered was the cumulative erosion of margins, the slow accounting that would determine whether the craft reached its next planned staging point with sufficient reserves to continue. The psychological environment aboard such a mission, though it deliberately avoided the language of characters, was nevertheless deep and textured. Habit was a fragile tool of sanity. Those who kept the ship running cultivated routines that mimicked planetary life. Periods of work and play, shared communal meals, rituals of remembrance for the world left behind. Yet the view from the portholes altered slowly into a different kind of horizon. Stars no longer behaved as passive pinpricks. Motion and Doppler shifts began to warp their appearance, compressing the forward cone of light and reddening the aft. The Voyager sky became a living map of velocity, a constant index of how far the mission had left the familiar and how fast it was approaching the stranger. The question of governance returned again and again, sharpened by distance. Who could legitimately authorize the change in mission profile? The answer in practice was a set of nested consent mechanisms. Initial mandates had been broad, with contingencies agreed in advance. Emergency panels were empowered to make time sensitive decisions according to pre-agreed ethical frameworks, and, crucially, the vessel itself carried autonomous protocols that could implement pre-ratified directives if communications delayed by light time became impractical. This architecture was an uneasy balance between democratic oversight and the pragmatic need for on-the-spot judgment. It reflected a species learning to share responsibility across temporal scales. As the corridor of travel widened, the decision to aim for a spiral arm brought with it a new kind of aesthetic, the sense of being part of a slowly embroidered pattern. The act of distribution, placing archives across the galaxy, was likened by some commentators to a form of cosmic knitting. Each deposit was a stitch, meant not to hold the fabric together, for that would be hubristic, but to leave a pattern that, if read by distant eyes, might register the fact of intent. There was something stubbornly human in that image, small, purposeful marks against a vast loom, scientific curiosity mixed with that aesthetic in the form of reconnaissance science at scale. Precursor probes were tasked with an additional purpose beyond hazard mapping to catalog natural repositories of stability, dense circumstellar disks, cold outer regions of quiet binaries, and the interiors of long-lived red dwarfs' comet belts were evaluated for their promise as long-term safes. The pattern was pragmatic and speculative simultaneously. Red dwarf systems offered longevity but could be flare active, while quiet mid-sequence stars might provide better radiation environments but exist in regions subject to different dynamical perturbations over galactic timescales. This cascade of considerations led to an emergent principle: distribute widely, design redundantly, and make the message as self-teaching as possible. The move to leave Alpha Centauri in pursuit of a dispersal across spiral structures was not a rejection of the first missions. Local cautiousness. It was an escalation of the same logic. If geology and plate tectonics erase the ephemeral on scales of millions to billions of years, then the only viable counter-strategy is to place many small bets across many different, long-lived physical contexts. The world that authorized the extension held two simultaneous narratives about the decision. One was sober and cautious. This was a methodical, probabilistic approach to survival of testimony. The other was more fragile and poetic. It was an act of witness, a refusal to let the species' fleeting light be wholly extinguished by geological appetite. Both narratives were true in different registers. Both were necessary to sustain the political will to commit resources to an enterprise that would, by design, return no immediate reward. When, finally, the outward spiral accelerated, when the ship's instruments reported the last clear signatures of the local neighborhood fading and the wider interstellar medium thickened into the hazy continuity of a galactic lane, the gesture that had begun as a technical decision crystallized into a cultural act. A civilization had chosen not merely to preserve objects, but to preserve an idea. That existence mattered enough to be risked against the quiet tyranny of time. The act was small on a cosmic ledger and enormous in moral calculus. It did not defeat the universe's indifference. It worked with the laws the universe provided and sought to fold human testimony into a frame where the odds of longevity improved. In the end, the decision to go farther was less about the destination than about a species' willingness to accept the conditions of deep time. To cross interstellar clouds and commit to deposits across spiral arms is to acknowledge that meaning can be probabilistic, distributed, and decentered. It is an admission that permanence is not a single fortress, but a constellation of durable traces. It is a practical expression of humility, an understanding that the cosmos will not guarantee audience or comprehension, but that the act of carefully making oneself legible, in math, in materials, in honest testimony, is itself a kind of ethical defiance. The ship that left Alpha Centauri and steered toward the spiral's dense lanes carried with it not only instruments and archives, but an answer to the question that opened this account. Faced with a ledger of separations and a slow, custodial erasure, humans chose to stitch, to scatter, and to hope that somewhere, some time, those stitches might catch on a mind that could read them. What does it mean to cross a galaxy and arrive at its rim, having felt the whole voyage as a single adult lifetime? That question is both technical and moral, a condensation of paradoxes, distances that would swallow generations if measured in the calendar of stationary clocks, and an interior time stretched or contracted by velocity until subjective years translate into geological epochs back home. The image that opens this segment is not a landscape, but an arithmetic of perspective, a corridor of motion whose endpoints are separated not only by space, but by competing ledgers of time. The vessel that makes this crossing carries a human-scale clock inside a machine that negotiates the galaxies in different geometry. For those aboard, the journey can be measured in decades. For Earth, and for the communities that shape the decision to send testimony outward, the same crossing registers as a procession of centuries, millennia, or more. The edge of the galaxy is therefore both a place and a moral fact. Arriving there means the planet that birthed the enterprise will no longer be the same audience that authorized it. The route across a spiral like the Milky Way is not a straight aesthetic, it is a mediated negotiation with structure. Spiral arms are not mere patterns of light, but concentrations of gas, dust, and young stars, environments dense with the raw materials of planet formation and, correspondingly, with the hazards of starbirth. Molecular clouds present themselves as regions of thickening opacity, where the interstellar medium grows from a whisper to a weather. Passing through one in a vessel traveling at relativistic fractions of light transforms the surrounding soup into a headlong storm. Sensors register particle flux rising, then spike. Hooded algorithms reconfigure shields and redirect expendable mass. Sacrificial layers ablate in predictable arithmetic, each gram of lost material accounted for in the mission's ledger. The prosaic choreography of shielding, sensing, and repair becomes the real drama of the crossing, a continuous, patient craftsmanship rather than the sudden flourish of cinematic heroics. As the craft leaves the familiar local spur and sweeps along the galactic plane, the texture of environment changes in ways that are both visible and invisible. Stars ahead compress into a brightened cone as relativistic aberration focuses light forward. Those behind grow pallid and recede in red-shifted isolation. The forward sky bluish shifts. Photons that once warmed instruments in a comfortable band push into higher energies, demanding thicker filters, stronger radiators, and relentless vigilance. The cosmic microwave background itself, once so placid and uniform, becomes a small concern when blue shifted by high velocities, contributing to an increased radiation bath from the forward hemisphere. Navigation in these conditions is intimate with survival. The same velocity that collapses subjective distance inflates the energy budget needed for shielding and maintenance. There are long spans of contemplative routine that punctuate episodes of acute engineering attention. Within the hull, life is made into rhythm, scheduled maintenance, redundant checks, archival and coding sessions, periods of sleep, and communal ritual that mirror the social architecture left behind. The preservation of habit is a technology as significant as any Whipple shield or magnetic deflector. Rituals keep social memory coherent. They are the cultural ballast that prevents institutional corrosion during transit. The occupants of the vessel become curators of a double archive, the physical packages entrusted to the void and the living memory that preserves the reasons for the act. Those two archives are not identical, and their fates diverge as the voyage stretches outward. The material artifacts will be subject to the physics of collision, sputtering, and corrosion. The living archive will be subject to entropy in the form of generational change, reinterpretation, and, ultimately, the possibility that those who remain on Earth are very different from those who sent the vessel. Crossing a spiral arm exposes the craft to a different cast of hazards from those encountered in the flatter, quieter interarm spaces. Supernovae are intermittent but devastating actors in the arms theater. A nearby stellar death injects a transient torrent of high-energy particles and a pulse of shock-heated gas that expands across light years. On human timescales, such an event looks like a dramatic spike in telemetry and a spike in priority lists, extra shielding, emergency safe modes, the sacrificial loss of expendable infrastructure. On cosmic timescales, these events are the agents of chemical enrichment. They seed the medium with heavier elements that will later become planets and, perhaps, life. The crossing is therefore ambiguous ethically. Spiral arms are both risky and generative, dangerous for a voyager, but essential to the galaxy's capacity to make complex chemistry. The decision of where to thread the needle is thus also a choice about the kinds of environments one hopes archives might one day be read in denser, possibility-rich places or quieter, lonelier interarm seas. The architecture of the ship's protections is a constant ledger against attrition. Micrometeoroid fluxes are logged as events. Each puncture or crater photographed and analyzed. Sacrificial layers are designed to fail in patterns that preserve internal coherence. Active fields pulse to deflect charged particles. Localized laser sweeps vaporize macroscopic threats detected by long-range scouts. The ship's forward geometry becomes an instrument for survival, its bow a palimpsest of impacts and repairs. Far from dramatic, these scenes are a succession of incremental adjustments, tiny victories over the universe's propensity for abrasion. They do not read as spacecraft epics so much as the slow, generational labor of a maintenance culture. Beyond the spiral arms, the disk thins. Metallicity drops. The population of stars grows older on average. The bright blue youth of arm stars is replaced by orange, by the slow breathing of population 2 suns. Fields of globular clusters appear as compact knots in the sky, ancient gatherings of stars that, for a human sensibility, are like fossilized cities of gravity. Their ages speak to epochs before heavy element abundance rose. to times when planets were rarer and the chemistry that supports life scarcer. To pass among them is to peer into a geological ledger of the galaxy itself, layers of stellar archaeology laid down across billions of years. For those aboard, instruments record spectra that map metallicity gradients, isotopic abundances, and the diffuse halos of ancient winds. These data are themselves part of the test of the mission. Whether an outward shipping of testimony to remote regions also yields scientific records that are a gift to those who remain. The ship is a nomad through structures that rotate and shear on timescales far longer than any human culture. The sun's orbit around the galactic center is a slow procession. The galaxy's spiral arms are not rigid spirals, but density waves, patterns that stars move through, over the span of decades that it takes the ship to cross long chords of the disk in subjective experience. The origin point, Earth's location, and the institutional framework associated with it, ages along the galaxy's slow currents. The phrase, Earth had drifted, captures multiple senses: the literal motion of the solar system in its orbit, the poor fit between the coordinate systems of the ship and home, and the cultural drift that transforms a polity into something else over the centuries. The ship's images of home, taken in those first faint hours of departure, become artifacts of a vanished geography. What remains on the planet is often a historical trace for later readers, not a live interlocutor. There are moments of profound cognitive dissonance that arrive without fanfare. A packet of data beamed home can arrive many subjective years later and find an Earth that has endured political rearrangement, linguistic shift, or institutional decay. The time lag between sending and receiving is not merely a communication inconvenience, it is a moral fact that affects consent, accountability, and the meaning of the mission itself. The decision to continue past Alpha Centauri and push toward the rim is thus an act that decouples one ledger of intention from another of reception. The departure is deliberate and democratic in its origins. The arrival at remote deposit points is irrevocable. That gap between decision and cultural continuity is the ethical core of the enterprise. Approaching the galactic rim, the environment becomes diffuse but not benignly empty. The halo is a domain of tenuous gas, high-energy particles, and dark matter's unseen gravitational scaffolding. Here, the same vulnerabilities that ruled through the disk persist in altered form. Cosmic rays are more penetrating, stray high-velocity objects are rarer but carry disproportionate kinetic energy when encountered. Thermal management becomes dominated by the low background temperature and the need to shed waste heat without the comforting radiative borrowing of denser regions. The archive's survival calculus changes. Rather than worry primarily about being ground into planetary churn, the designers now worry about slow sputtering and the statistical hazard of rare catastrophic collisions over billion-year timescales. The strategy therefore becomes one of distribution and redundancy, to scatter meaning across many stable niches so that the statistical chances of a single packet surviving increase. Aesthetic considerations intertwine with this probabilistic calculus. The choice of where to lodge an archive is not merely pragmatic, it is communicative. A quiet orbit around an old, stable red dwarf might preserve a record for far longer than a planetary surface buffeted by storms. Embedding an archive into the heart of a long-period comet provides insulation from the dynamical churning of planetary geology, placing it in the shadow of a dark, cold, minor body limits thermal cycling. Each choice encodes a judgment about what permanent can realistically mean. The rim, taken as a collective of many such choices, becomes a museum of human humility. Small, carefully engineered deposits arrayed like stitches along the galaxy's edge. The psychological effect of arriving at the rim is subtle and layered. There is an immediate technical satisfaction in successful deceleration and in the safe placement of packages beyond planetary dosages. But there is also the quiet grief of distance. Images of Earth, once central, are reduced to spectral coordinates and archived metadata. The living questions about home's future are now, in many cases, questions that will be answered without the originators present to interpret them. That grief is not melodramatic. It is a low, persistent recognition that the craft's act of preservation changes the relationship between cause and consequence. The mission has traded immediacy for durability. It has accepted the moral cost that some testimonies may be read only by minds that did not share the world that produced them. This trade-off is visible in the way archives are encoded. Designers anticipate interpretive poverty and therefore invest heavily in self-teaching structures. Mathematical sequences, physical constants, isotopic ratios, and carefully layered images provide scaffolds for decoding. Multiple media are used, ceramic matrices for their stability, noble metal inscriptions to resist corrosion, and nested mechanical patterns that can be interpreted by senses or by biological percepts unfamiliar to human senses. Each layer is intended to be a bridge across the abyss of changed context, a pedagogical ladder that begins with universal anchors and climbs to cultural detail. The rim is therefore more than a repository of objects. It is a didactic landscape, a set of invitations to future intelligences to reconstruct not only facts, but the very project of reflection that prompted their dispatch. There is a final, quiet irony in reaching the rim. The very success of making testimony durable in the absence of geological erasure turns the problem back on interpretation. The longer an artifact survives, the greater the chance that its readers will be temporally remote in ways that complicate understanding. The rim becomes a theater for the tension between physical survival and semantic legibility. A package could lie untouched for hundreds of millions of years, its ceramic inscriptions still legible, its isotopes intact, and yet the cultural keys necessary to make sense of the deposit may be absent. That uncertainty does not deter the rationale for distribution, rather it refines it. The designers accept that absolute guarantee is impossible, so they aim for a maximally plural set of interpretive pathways, increasing the probability that at least one reader, at one future time, will possess the cognitive tools to understand the testimony. When the crossing concludes and the edge is reached, the reflective voice of the project shifts from technical reassurance to philosophical humility. The vessel has stitched its thread through the galaxy, not to make a monumental claim of permanence, but to offer a set of carefully prepared traces. The action is an ethical refusal of erasure. If the planet's surface cannot be trusted to hold memory forever, then memory can be placed where physics is less hungry for the ephemeral. The rim is not a fortress against oblivion. It is a probabilistic margin in which the odds of remembering are measurably improved. Ultimately, the arrival at the galactic edge reframes the initial question of this account. The silence between a thought and a distant star is no longer just a wait, it is a space for deliberate action. The galaxy's expanse and the universe's indifferent ledger of time and distance do not oblige despair. They invite a form of careful audacity, to design testimony robustly, to distribute it wisely, and to accept the moral complexity that accompanies all choices made at a distance. The edge of the galaxy is therefore less a finishing line than a new stage for the same human work that began near Earth's shore, cataloguing, composing, and daring to be legible in an architecture of separations that will always test the limits of what it means to be remembered. What does it mean to come home to a planet that has been writing new chapters in a language the original authors no longer understand? To pose that question is to sharpen the feeling of time from an abstract ledger into a blunt instrument. Millions of years are not merely a longer stretch of calendar, they are a reweaving of ecosystems, a rerouting of continents, an alteration of the very chemistry that once made certain memories possible. The narrator begins here with that question because the encounter with Earth's distant future insists upon thinking about memory as a practice that must survive geological impatience, biological creativity, and the slow, indifferent arithmetic of chemistry. When a vessel returns after an epoch, the first evidence of change is not an obvious headline, but a subtle rearrangement of relations. Gravity and the orbits remain the same. The physics that govern departure has not renegotiated its contracts. Yet the planet's face is different in ways that are both scalar and qualitative. Coasts have migrated. Mountain ranges have grown new crowns and worn different basins. Seas that once cradled cities may have retreated into basins unknown to the memory of a human child preserved in a digital archive. Plate tectonics, that slow, patient engine of erasure and creation, has rearranged the lithography of continents. A returner's eye, trained by instruments for anomalies, for isotopic signatures, for the fingerprints of intentionality, must learn to read a palimpsest where human marks have been partially erased and partially folded into new strata. The physical traces that survive are themselves a kind of grammar. Certain markers persist longer than others, isotopic anomalies embedded deep in bedrock, transuranic residues created by fission reactors, the subtle enrichment of rare elements from industrial activity. Plastics and synthetic polymers do not vanish on the scale of a few centuries if they have been buried in anaerobic sediments. Their chemical backbones slowly transmute, but intermediate compounds remain legible. Steel and concrete crumble under the combined assaults of water, acid, and microbial colonization, but when buried in anoxic, sediment-rich environments, river deltas turn to peat. Submarine canyons, sealed by silt, their structural echoes can endure far longer than surface monuments. Even when architectural forms are ground down to indistinguishability, the chemical signatures of production, massive shifts in carbon isotopes from industrial combustion, mineralogical traces from smelting remain as metabolic scars on the planet. There is also a class of artifacts that is more durable by deliberate design. The earlier account argued for the outward shipping of testimony to protect against terrestrial forgetfulness. The same logic applies to the reverse scenario. A civilization that anticipates deep time survival may have embedded its most important records into places that geology is unlikely to touch, the cores of stable basalt flows, deep frozen permafrost locked by continental shields, the interiors of long-period comets parked into cold orbits. Those records, ceramic tablets fired to high temperatures, noble metal archives, isotopically tagged geological implants are less likely to be reworked by subduction. Instruments returning to Earth look for those durable caches, interpreting them as the most likely sites of legible human presence. To encounter life that has flourished on the same planet after millions of years is to meet evolution's blunt capacity for novelty. Evolution is neither teleological nor sentimental. It is a relentless experimenter. For a biology shaped by a human-dominated Holocene, the Anthropocene's perturbations become a substrate for selection. In some imagined trajectories, human descendants survive not as recognizable Homo sapiens but as lineages that have adapted. Morphologies and cognitive architectures to new niches, semi-aquatic communities adapted to a world of higher sea levels, arboreal populations in forests regrown over former metropolitan basins, symbiotic collectives that integrate biological tissue with pervasive microbial networks. In other scenarios, the dominant intelligence is not a descendant of the primate line at all. Engineered microbes, selected for industrial resilience or bioremediation, could evolve cognitive complexity in ways unexpected to their creators. Synthetic organisms liberated from classical genetic constraints might spread traits that ripple across food webs. The point is not to enumerate outcomes, but to emphasize the epistemic difficulty. Recognition must be reconceptualized. The habit of looking for faces and bipedal posture will mislead. The true test of kinship is not morphology, but continuity of purpose and information. There is the painful option as well. Humanity might be absent in any biological sense. Extinction need not be total annihilation. It may be a collapse into a web of disconnected legacies. Ecosystems may recover, rebalancing in the absence of human predation. Forests reclaim pavement, lichens colonize glass, soil microbes degrade hydrocarbon residues. Over millions of years, ecologies reassert niches. When life fills the vacuum, it does not replicate the past. New megafauna might emerge, mammally forms or avian superlatives that exploit niches abandoned by humans, or small, tireless insectoid lineages that metabolically capitalize on the detritus of industrial structures. In such a world, there is an emotional weight to the return. The vessel's instruments register abundance and complexity, but the abundance holds no human eyes. There is both relief and a kind of mourning in seeing a thriving biosphere that is not watching back. That mourning is compounded by the nature of memory. The human drive to be legible etched names, recorded histories, curated cultural packages assumes a reader who shares conceptual keys. Across millions of years, languages shift into unintelligibility, symbols lose their syntactic anchors. An archive might physically survive, yet its meaning can erode faster than its surface. The archaeological imagination of a returner must therefore be pedagogical. Instruments look first for metastructures, primordial anchors like physico-chemical constants, repeated mathematical series, universal patterns that an intelligent reader might reconstruct without historical continuity. In the best scenarios, the depositors of earlier epochs anticipated the problem and layered their records with self-teaching. Scaffolds, starting from prime numbers and ratios, building toward pictorial lexicons and then toward cultural contexts. Those artifacts, if found intact, are both a triumph of foresight and a reminder that survival is only half the battle, legibility is the other. When a living intelligence is encountered, whether a divergent human descendant, a bioengineered intelligibility, or an emergent non-human mind, the first question is not technological but ethical. What responsibilities does a returning civilization hold toward life that has evolved in its absence? The documentary voice hesitates at the anthropocentric urge to claim lineage. Kinship may be incalculably complex. A descendant species that has never shared a common cultural narrative with the originators might nevertheless carry essential genetic fragments, epigenetic motifs, or epiphenomena derived from human activity. Alternatively, a nascent intelligence may have appropriated degraded artifacts, reinterpreting them as ritual objects. The returning public must confront the fact that possession and recognition are not the same. Even the notion of return is compromised. The planet has not been waiting, it has been changing, experimenting, and making life where it can. Observational instruments play a crucial role in this encounter. Spectrometers read atmospheres for biosignatures of unexpected composition ratios shifted by industrial legacy, gases introduced by ancient terraforming projects, methane cycles remodeled by new metabolic pathways. Imaging systems seek morphology at multiple scales, the re-emergence of perovskite cloisters and subterranean caverns, signs of biogenic architecture, patterns of erosion around known latitudes. Paleogenomics, where possible, reaches back into sedimentary DNA to detect homologous sequences. Such matches, if found, are a biochemical echo more persuasive than a weathered statue. But there is a methodological humility to the approach. Data are provisional, and interpretations are contingent. The same patterns, say, a regular lattice embedded in crystalline growths, could be a geochemical anomaly, a product of biological construction, or a remnant of a long-past technological process. The responsible narrator refuses dramatic certainties and follows a slower, scientific rhythm of conditional inference. Encountering future life also reframes the archives that earlier departers placed away from Earth. Some of those outward testimonies might have been designed to be legible by a non-human intelligence, mathematical progressions, resilient isotopic markers, DNA fragments encoded as deliberate signals. If those interstellar artifacts return in the observational catalogue, if their beacons are found, or if their influence is detected in exogenic material, the meeting between terrestrial pasts and extraterrestrial futures becomes more layered. The planet's own story will then appear in dialogue with scattered traces in deep space, a distributed memory of a species that both fled and remained, that scattered testimony across the galaxy while also leaving durable specks in its own geologies. There is another, less acknowledged dimension to this encounter, the psychological architecture of those who return, even if the they is institutional rather than individual. The human propensity to narrate is a cognitive habit. The story of origin and home is foundational to identity. When that narrative is ruptured, when home no longer corresponds to the moral or biological community that created the narrative, the emotional landscape shifts from reunion to estrangement. Observers feel a paradoxical intimacy and distance, intimacy in recognizing chemical signatures or seeing a familiar gene motif, distance in the incomprehensible remaking of forms and habitats. The emotion is not reducible to sadness. It is a complex cognitive state combining wonder, grief, curiosity, and a muted ethical unease about claims of ownership. Practical politics complicate the philosophical register. If any return involves the possibility, however remote, of contact, there are bylaws waiting in the wings. The ethics of intervention are not merely hypothetical. If a descendant intelligence is vulnerable to introduced pathogens, or if an archival deposit has cultural significance for local beings, the returning civilization bears an obligation to avoid harm. The old doctrine of do no harm mutates into a tough procedural calculus when applied across evolutionary time. Contamination risks, for instance, are not limited to microbes, informational contamination, imposing an alien semiotic frame upon. A living culture can alter developmental pathways irreversibly. The documentary voice here underscores a lesson from conservation biology. Well-intended interventions can be catastrophic if they fail to respect the autonomy of emergent systems. There is, finally, a metaphysical pivot in the encounter. Recognition that survival and remembrance are not synonymous with continuity. A species can leave abundant traces and yet be a poor ancestor. Alternatively, a species might leave almost no durable artifact and have influenced the evolutionary trajectory of other organisms in ways that are profound but untraceable in our conventional archives. Documentarians' role is to hold both possibilities at once, to report the technicalities of isotopic anomalies and the deeper human questions about what it means to have mattered. The return to a changed Earth is thus less a homecoming than an ethical audit. It tests earlier assumptions about legacy, destiny, and responsibility. It surfaces a double humility, the humility of engineering, recognizing the limits of what materials and messages can sustain, across geological hunger, and the humility of ethics, acknowledging that being remembered by one's descendants may not be the ultimate good if those descendants are better served by an autonomous developmental arc free from the impulses of the past. The planet's future life, whatever form it takes, is not merely a backdrop for human nostalgia, it is the continuation of Earth's own narrative, in which humans were a brief, influential passage, and not the final authors. In the closing register of this part, the narrator circles back to the original, uneasy question: does remembrance require an audience that recognizes the original teller? The answer, the account suggests, is ambiguous. Memory may be preserved materially, faithfully, and yet be unreadable. It may be transmitted and later reinterpreted by forms of life that owe no direct loyalty to their antecedents. That ambiguity does not reduce the moral worth of the attempt to preserve testimony, rather it reframes that worth. To craft messages and durable records across deep time is to accept the possibility of misprision and to commit to honesty in what is preserved, both luminous achievements and admitted failures. It is to accept that any future encounter with the living planet will be a meeting with the other, whether that other calls itself human or not. The encounter with Earth after millions of years is, in the end, a reframing of scale and sympathy. It invites a practice of stewardship that acknowledges the planet's capacity to outlast any single species and to recompose its history in ways that may surprise and unsettle. The returner's instruments may register isotopes, lattices, echoes of DNA. Their analysts may deduce lineage trees or declare extinction. But the most humane response is an ethic of witness, to record, to interpret with care, to avoid hubris, and to recognize that being remembered is a modest achievement within a cosmos that measures eras differently. The planet's future is not a destination to conquer, but a conversation to be approached with patience, humility, and a deliberate intent to do no harm to the living processes that now hold the ground once occupied by human footsteps. What does it mean to extend the duration of a life so that it can keep pace with the slow, patient calendars of the cosmos? That question is not merely biological, it is political and moral, a hinge upon which the entire enterprise of deliberate testimony swings. If mortality sets the horizon of ambition, then prolonging healthy, sentient continuity pushes that horizon outward. In the speculative ledger of interstellar witness, longevity technologies are less an act of vanity than an infrastructural multiplier. They change what projects are conceivable, what memories can be carried, and how responsibility is distributed across time. The hypothesis is straightforward. If anti-aging science can significantly reduce or reverse senescence in human bodies and minds, then crews, or their successors, biological and synthetic hybrids, could undertake voyages whose subjective durations stretch across decades and centuries without the need for cryopreservation, radical mind transfer, or multi-generational guardianship. In such a scenario, the constraints that once made interstellar missions problems of institutional patience and generational delegation are reformed into problems of sustained competence. The ship is no longer a sealed capsule for a few years of daring. It becomes a mobile culture, a living archive that preserves not only data, but the interpretive frameworks, ethical instincts, and procedural memory necessary to steward the mission's aims. How might those technologies manifest? Contemporary research sketches a panoply of threads that could, in principle, be woven into a durable anti-senescence program. Senolytic medicines that selectively clear dysfunctional cells, gene therapies that stabilize telomeres and restore chromosomal integrity, systemic reprogramming techniques that reset epigenetic marks while preserving identity, metabolic interventions that recalibrate nutrient-sensing pathways to reduce accrual of damage, and organ repair technologies that mend accumulated wear. Complementing the biological are cybernetic and cognitive supports, neural prosthetics that back up and augment memory, adaptive interface layers that translate degraded sensorium into coherent representation, and modular organ replacements built from engineered tissues. Taken together, these approaches would alter the failure modes that have shaped human history: frailty, cognitive decline, the demographic rhythms of succession. The practical implications for interstellar work are immediate and profound. A crew whose members can remain vigorous and lucid across half a century or more can pursue mission profiles that trade speed for deliberation, that pause to perform careful depositions, that establish multi-century observational programs, that repair and refit craft in situ rather than rely on redundancy shipped from home. Anti-aging reduces the ethical burdens of sending young bodies on preposterously long journeys they will never see concluded. It preserves agency in those who must make hard calls decades from launch. It allows a cultural continuity aboard ship that strengthens the fidelity of the testimony being carried outward. Yet longevity is not a neutral amplifier. Extending life changes incentives and kinds of risk people are willing to bear. When individuals expect a long, coherent, subjective future, They invest in long-term institutions. They are more likely to accept deferred payoffs and to build patience into civic architectures. At the same time, those same individuals may become more conservative in cultural taste. The social and psychological patterns of a sustained cohort can ossify into an archive of norms that resist adaptation to new contexts. An onboard culture that seeks to preserve continuity may, paradoxically, become less able to interpret and translate its own testimony for others. Memory stabilizes, but flexibility can atrophy. There are also political consequences that ripple back to Earth. Longevity is not simple medicine, it is a distributional technology. If anti-aging becomes an enabler of interstellar agency, questions of access become determinate. Who receives extended lives? Who is permitted to join voyages that will stretch institutional and planetary resources across centuries? The ethics of consent shift, not only across generations, but across the inequality gradients of those generations. A species that can keep a fraction of its people youthful and effective for an extra century will confront new fault lines. Will extended life be a common good, democratically governed? Or will it concentrate decision-making power into the hands of an enduring elite who make choices about the fate of memory on behalf of those who do not share their elongated horizons? Technically, extended lives relax some constraints and tighten others. With longer subjective time available to crews, mission planners can afford slower cruise regimes and more elaborate braking schemes that save mass and reduce the energetic costs of high relativistic gamma factors. The Lorentz calculus remains stubborn. The physics of time dilation still separates ship time from planetary time, but extended biological endurance makes certain mission profiles more humane. Crews can experience voyages measured in decades without recourse to suspended animation. That can be used to reduce the environmental and moral costs of investing planetary resources in outracing cosmological expansion. Instead of a frantic, maximal speed push to outrun horizons, societies might choose sustained, distributed dispersal combined with patient stewardship, but this apparent liberality hides deeper trade-offs. Longer-lived crews permit projects whose beneficiaries may not be coeval with those who authorize them. A person who will live a century remains accountable in a way a one-generation agent cannot be, yet that accountability is still finite within the sweep of cosmic epochs. 100 years is a brief stanza in the galaxy's long poem. The presence of durable, agentive bodies on ships alters decision architectures, but it does not dissolve the fundamental asymmetry between those who act now and those who will read the acts much later. Longevity tech magnifies responsibility rather than absolving it. It places heavier weight on the protocols for choosing what to preserve, what truth to record, and when to accept the moral chance that any given testimony will be rendered meaningless by context loss. That moral architecture connects intimately with a cosmological constraint, a moving frontier that might be called the Q boundary. The term is meant to be evocative rather than strictly canonical. It references a family of cosmological thresholds that emerge when the universe's expansion accelerates. The most relevant of these is the cosmological event horizon in an accelerating universe, the practical line beyond which light, emitted now, will never reach an observer in the far future. In classical parlance, this is tied to the deceleration parameter, Q, and to the broader dynamics of dark energy. But the lived reality is simple and inexorable. Space is stretching, and that stretching will, over time, place vast regions forever beyond causal contact. The Q boundary, then, is a moving concept, an asymptotic limit that depends on the model of cosmic acceleration and on the epoch in which the observer acts. Under the concordance lambda cold dark matter model, the present accelerated expansion implies that galaxies beyond a certain comoving radius will recede so rapidly that no signal sent today can ever reach them in the cosmic future. That radius is not fixed. It shifts with time and depends on the energy content of the cosmos. For planners concerned with long-term testimony, it is a deadline disguised as physics, a horizon beyond which an act of will, a launched message, a seeded archive cannot change the course of distant, separate histories. Anti-aging technologies change the agency available near that horizon. A crew capable of decades of sustained mission work has a longer window in which to attempt to send deposits beyond the Q boundary, to seed outposts in more distant gravitational wells, to place archival packages in locales that will be carried outside the reach of terrestrial geological digestion. In effect, longevity buys time for logistics, a chance to prepare smarter deposits, to scout safer orbits, to orchestrate distributed redundancy across a wider sweep of the galaxy. That is a profound capability. It changes the calculus from a frenetic sprint to a patient, distributed program of dispersal. But the Q boundary resists hubris. No matter how long-lived the carriers, the boundary is a physical limit on causal influence. An agent cannot make a causal connection where none is permitted by space-time geometry. Thus, a civilization that extends subjective life to reach farther and longer must still grapple with the hard fact that some regions will remain forever unreachable. The presence of longevity strengthens the ethical weight of selection. If it is impossible to reach all places, which places should be chosen? Should priority go to nearby systems that are more likely to host interpreters in the nearer future, or to remote, cold reservoirs that promise maximal material stability over geological and cosmological timescales? The question is not just technical, it is a moral taxonomy of what is worth saving and how to balance probability against desire. There is an additional, subtle effect of the Q boundary that longevity heightens. By elongating subjective horizons, a society will be tempted to invest in the far future in ways that displace present needs. The moral temptation is to defer tough local problems, climate repair, equitable resource distribution, the stewardship of fragile biospheres, in the hope that long-lived explorers will vindicate those present sacrifices with monuments in the dark. Such a bargain risks becoming an abdication. To extend life for voyages without coupling that extension to a stiff ethic of local responsibility creates the possibility of a civilization that writes itself into the cosmos at the same time it impoverishes its cradle. The Q boundary then becomes a mirror. The moral form of the limit reflects back the choices made at home. There are also technological limits that longevity cannot erase. The energetic cost of sending mass to distant neighborhoods, the erosive hazard of interstellar medium at relativistic speeds, the need to provide long-term thermal management, none vanish with longer E-lived crews. Indeed, some costs grow more acute. The longer a material or machine must operate without resupply, the more rigorous its tolerances must be. Materials, science, fault-tolerant architecture, and self-repair systems become as central as the life sciences that keep minds and bodies lucid. An immortal mind cannot perform its duties if the habitat it depends upon slowly corrodes. Durability is a composite property. There is also an epistemic problem intensified by longevity. A living culture that preserves an unbroken chain of interpretive tradition may become peculiarly skilled at encoding testimonies. That will be legible to itself or to those like it. But the longer the chain, the stronger the temptation to inscribe a record that presumes the survival of that chain's semiosis. Deep time always threatens the loss of context. A long-lived crew might overinvest in continuity assumptions, languages, symbolic codes, aesthetic forms that future remote readers cannot reconstruct. The antidote lies in humility. The more one invests in long-range deposits, the more one must prioritize universals, the constants of physics, the rhythms of prime number sequences, redundant multimodal scaffolding, and the more one must accept that legibility cannot be guaranteed. Finally, the interplay of longevity and the Q boundary reframes the notion of legacy, a species that can extend the lifespan of its agents and push the frontiers of deposition into the remotest reaches of causal contact might create a distributed network of testimonies threaded across space and time. But the meaning of legacy ceases to be merely the survival of particular artifacts. It becomes an ethic of pluralism and approximation. Rather than seeking a single monumental inscription that proclaims, "We were here," the wiser project is to scatter many smaller gestures, varied, honest, pedagogically layered, and materially resilient. The probability that at least one deposit will be encountered and understood increases not linearly but combinatorially with diversity. Longevity makes such a distributed strategy practicable because living agents can iterate, learn, and adjust over long horizons. The Q boundary makes it necessary because no single act of burial can reach everywhere. In the end, the speculative marriage of anti-aging science and long-range dispersal is neither a technological panacea nor a moral carte blanche. It is, instead, a refinement of responsibility. It multiplies the means by which a species can attempt to escape geological forgetfulness and to place testimony where the planet's processes cannot digest it. It also intensifies the imperative to weigh costs in a fuller moral ledger. Costs to present communities, costs in material resources, and costs in the kind of cultural humility that deep time requires. Extended lifespans allow more careful stitching of memory across the dark fabric of space, but they also demand more careful choices about what to stitch and why. The Q boundary remains a silent interlocutor in these decisions, a geometric fact that will, in the fullness of cosmic time, prune the set of possible conversations. To act with longevity is to accept not only the opportunity to send better and further, but the limit that some voices will simply never be heard. The noble act is not to imagine that immortality can conquer causality, but to design testimony with an understanding of the boundary's contour, to be honest in what is preserved, generous in the distribution of what is sent, and humble in the claims made for what survival across the void will mean. Viewed from that angle, anti-aging becomes less a technology for evading finitude than a tool for practicing a deeper stewardship. It gives a species the capacity to write more carefully into the ledger of the cosmos, but it also requires a tempering of ambition with prudence. The long crew, the long ship, the long archive, these are instruments of patience. The Q boundary, exacting and indifferent, is a teacher. Together they shape a posture toward deep time that is neither triumphal nor fatalistic, an effort to be legible, responsibly and honestly, in a universe that will keep only what endures and forget what does not. What is the moral shape of a journey that is not merely far, but finally beyond return? That image, not of a ship crossing an ocean, but of a threshold that, once crossed, makes turning back impossible, is the thought that opens this segment. To aim at the farthest reaches of the observable cosmos is to choose an endpoint defined by cosmology itself, a moving horizon set by the universe's expansion. At an observational distance on the order of 8.3 billion light-years, the nature of causality begins to change. Beyond certain scales of co-moving distance and given the present acceleration of cosmic expansion, regions of space recede so rapidly that no signal launched from them today can ever again touch a solitude that remains inside. Our causal bubble. A voyage to such remote neighborhoods is not simply a test of engineering, it is an ethical commitment to finality. It helps to name the scale. 8.3 billion light-years is not the edge of physical space. The universe stretches on, perhaps infinitely, but it is a practical front, a distance where the arithmetic of expansion guarantees an irreversible separation for messages and for bodies that choose to cross it. Imagine a one vessel, all the careful trade-offs and protections discussed earlier, pushing its way through interstellar lanes, threading spiral arms and slipping past the galactic rim. Each stage is a choreography of maintenance and modest heroism. But beyond a certain cosmological radius, the rules change in a way that transcends engineering. The metric that measures if a photon sent home will ever arrive begins to favor escape. The spatial expansion itself outruns light, establishing pockets of the universe that are forever causally disconnected. To go there is to write an epitaph in the present tense. There are practical consequences before the philosophical ones. At large redshifts, the universe behaves like a river with a current that grows over time. The farther one travels, the less meaningful are notions of round trips. Rotational symmetry and local mechanics still hold in the craft's hull. Thermodynamics still insists on radiators and shielding. But cosmology imposes a global boundary condition. The expansion driven by dark energy produces an event horizon in which proper distances increase so quickly that even light, emitted now, will never intersect observers who remain within the original causal patch. The calculators and mission design centers can compute velocities and delta EEF budgets, but they cannot alter the form of space-time expansion. The law is not one of neglectable friction. It is an arena in which any hope of return must be stated as a clear, upfront impossibility. That stark impossibility reframes the meaning of the voyage. Earlier arguments for outward deposition of testimony were pragmatic. Send artifacts beyond the churn of Earth because plate tectonics will otherwise erase them. Those were acts of preservation aimed at increasing the probability that something of a civilization might survive and be found by a decadal or geological reader. The act of crossing to cosmological distances adds a final quality to the choice. It turns preservation into exile. Sending an archive so far that the origin system is forever unreachable is to accept that the preservation will be orphaned from the world that birthed it. The archive will endure as an orphan testimony, material and perhaps legible, but without the possibility of direct, reciprocal conversation with its creators. This is where the moral cost becomes explicit. The earlier ethics of distribution, scatter widely, design redundancy, build self-teaching scaffolds, still apply. But now they sit against a backdrop of volitional abandonment. The deliberative question is no longer only about optimizing survival probabilities, it is about whether it is justifiable to commit to a program of irreversible dispersal. Will successive generations of a species consent to deposit their culture and genes at a radius where return is physically impossible? Who decides that they should? What obligations are owed to those who remain, to the biosphere left behind, and to the many generations whose lives are shaped by the resources spent in pursuit of such distance? The answers are not technical alone. They are social and political, and they require deliberative institutions capable of long-term stewardship. The decision to launch a mission whose destination lies beyond the causal horizon is a civic act performed on behalf of people. Who cannot foresee its completion? It is the type of choice that demands unusually robust forms of social consent, mechanisms that must reckon with the fact that the moral ledger extends across centuries of shifting norms. The science panels, ethicists, and engineers can lay out the trade-offs, the amount of mass converted to archival payloads, the environmental cost of building and fueling beamed propulsion facilities, the opportunity costs on planetary health. But their calculations are only half of the argument. The other half is cultural. What it means for a species to deliberately commit to a future in which it will have no interlocutor back home. There is another dimension of the enterprise that complicates the ethics, the interpretive gulf. The very act of placing a durable object in a faraway system assumes that future readers exist and can be reached by the forms chosen. The project of building self-teaching keys, nested mathematical sequences, isotopic anchors, redundant physical formats, mitigates the problem but cannot guarantee comprehension. At cosmological distances, where even the photons that carry a record age into long wavelength oblivion, the practical question is whether the deposit is likely to be discovered, and, if discovered, whether any intelligence that finds it will have cognitive frameworks or sensory modalities compatible with the encoding. The longer the chain of causal silence, the more speculative these assumptions become. To commit to irreversible dispersal is therefore also to bet on the resilience of intelligences that may arise in foreign conditions, and to hope they will have the curiosity and capacity to interpret a foreign testimony. The physics place further constraints on feasibility. The energetic cost of propelling mass to relativistic speeds remains enormous, and the addition of carrying mass to decelerate, to deploy braking sails, or to seed delivery agents into stable orbits in distant systems consumes more propellant and more ingenuity. The intergalactic medium, even 10 billion light-years out, carries particles whose relative interactions scale with speed. Micrometeoroid impacts at fractions of c remain catastrophic, unless carefully mitigated. Heat rejection becomes acute as onboard reactors work for decades to sustain life and power. A mission that aims at 83 billion light-years cannot be the same sort of mission as one that targets Alpha Centauri. It must be thought of as an enterprise of distributed logistics and multi-stage deposition, with contingency plans that anticipate attrition across millennia. There is also, paradoxically, a kind of aesthetic gravity to that finality. The irrevocable nature of the act forces a certain humility into design. Where once the aim might have been to plant flags or to claim scientific firsts, the act of sending testimony beyond the causal horizon reframes success as fidelity to truth, honesty about a species' history, its failures, its ethical missteps, as well as its achievements. The pressure is thus to craft messages that are not mere monuments to triumph, but sincere accounts of existence. Cultural curators argue in those deliberations that if the archive will be read without the possibility of reply, it ought to tell the full truth, the luminous and the shameful, the scientific and the moral, the poetry and the policy mistakes. An irreversible deposit asks not just to be remembered, but to be understood on its own terms. That demands pedagogical craft more than rhetorical flourish. The solitude of such missions is not purely abstract. For the agents who undertake them, or for the societies that sustain them, the knowledge that return is impossible shapes behavior. It influences what artifacts are chosen, how candid the records are made, and the degree to which the mission is framed as an act of witnessing rather than conquest. Missions of irreversible dispersal therefore tend to exhibit two common virtues, a high degree of redundancy and an ethic of transparency. Redundancy multiplies the odds that at least one package will survive physical attrition. Transparency means the archives refuse self-aggrandizement in favor of honest testimony. Together, those virtues shift the mission's meaning from triumphalism towards stewardship. There is a cosmological irony here. The same expansion that makes return impossible is the same process that thins the universe into a quieter, less collisional future. Regions that currently look hostile might, in the very long term, offer stability in the sense that they will be less disturbed by the local rearrangements of galactic structures. The cosmic expansion eventually carries distant galaxies beyond the ability of light to travel between them, isolating pockets of matter into lonely islands. An archive placed beyond the causal horizon today will remain isolated tomorrow, unread perhaps, but also free from the planetary churning and star-forming violence that erases surface traces. The calculus is therefore cruel and pragmatic at once. One may gain physical stability at the cost of reciprocal comprehension. That cruelty asks another, deeper question about meaning. Why would a species tidy an archive for a future that cannot answer it? Part of the reply is that such acts are an expression of a long-horizon responsibility. Civilization is not merely the sum of the living, it is also a set of practices that binds past to future. Even if no one reads an archive, the act of preparing it confers a discipline on the present. It encourages a species to reckon with its own limits, to be honest about what is worth preserving, and to train institutions to act beyond immediate gratification. In this sense, preparing irrevocable testimonies is less a vain hope for posterity and more a pedagogical exercise in cultivating a certain kind of collective prudence. There are still more concrete reasons to proceed. The distribution of archives beyond the horizon diversifies the portfolio of persistence. Geological processes threaten surface memory, cosmic hazards threaten orbital memory. By scattering artifacts into distant, causally isolated locales, a civilization increases the number of independent trials against the statistical odds of loss. If the goal is to maximize the probability that something of human deliberation survives across cosmological time, then distribution, even into places of no return, is rational. It is an application of probabilistic humility, except that any single strategy may fail, and therefore diversify across multiple independent strategies, including the extreme one of irreversible dispersal. Ethically, however, that diversification must be bounded by responsibility on the home planet. Resources devoted to casting artifacts into irrevocable darkness are resources not spent on the health and flourishing of present life. The temptation to externalize care onto a hoped-for archive is real. The act of sending memory into the cosmos can become immoral. Fig leaf for failing to repair the world that makes the act possible. The nobler posture, and the one most congruent with stewardship, is to balance outward preservation with inward repair, to make careful deposits while also committing resources to ensure the cradle remains a good place for those who will continue to live there. Doing otherwise would be a form of cosmic colonialism, leaving a tidy record while abandoning the living. Finally, the existential weight of irreversibility gives the act of creation a peculiar dignity. To send testimony to the cosmological horizon is to accept being unmatched by the cosmos, to speak into a silence that may never speak back. That acceptance has a moral texture akin to many forms of ethical practice. It is analogous to acts performed for the benefit of future generations who may never know the names of those who labored for them. It is a refusal to allow the shortness of human life to excuse a lack of attention to the long term. In that sense, the project is not triumphalist, but humble, an admission that the cosmos will not bend to human wishes, and a decision to leave nonetheless, a careful, candid record. In the end, the limit at roughly 8.3 billion light-years is not merely a line on a cosmologist's chart. It is a moral horizon. Cross it deliberately, and the act becomes a form of exile, deliberate, engineered, and final. Choose to stop before it, and the effort remains within the domain of potential reciprocity. Either choice is defensible only through sustained public reasoning, through institutions that can weigh costs across generations, and through a cultural ethic that prizes honesty in what we elect to preserve. The universe imposes these choices by the work of expansion. It does not judge them. For a species that has learned to speak, to record, and to care, the question is not whether one can cross the horizon, but why one would choose to do so. The answer will be found, if at all, at the intersection of prudence and hope. Prudence in engineering and in stewardship at home, hope that an honest, well-crafted testimony might one day be read by a mind willing to listen, and a willingness to accept that even unheard testimony is a moral act of bearing witness to a life that once thought itself worthy of preservation. 12. K. What does it mean to send a witness into a cosmos that is itself dying? The question arrives not as a technical footnote, but as a moral fulcrum. If a species elects to continue beyond every return line, beyond every causal tether, it must confront the fact that the very material of history will not endure. Time, in its longest registers, is not merely a slow eroder, it is a transformer of reality. At an age on the order of 10^-41 years, the ledger of matter and information has changed its entries. photons, the building blocks that once held the architecture of cities and the chemistry of thought, have quietly dispersed. The universe has thinned into what can only be called the void. The figure 10 at 41 years is enormous in a way that eludes ordinary intuition. If the age of the Earth were compressed to a single day, the interval between now and that distant future would be a span that dwarfs the entirety of human history into a breath so small as to be unimaginable. Yet numbers are more than cold extravagance here. They are the grammar of consequence. Proton decay, if it is part of cosmic fate, removes the chemical scaffolding of life. Atoms themselves, the crucibles of memory, metabolism, and material inscription, unbind. The world that made tapes and ceramics and seed banks ceases to be the world those artifacts require to mean anything. Physics, on geological and cosmological timescales, becomes the ruthless editor of narratives. Under those conditions, a voyage that is continued beyond the possibility of return stops being a project of preservation in any straightforward sense and becomes an ethical act of finality. The outward motion no longer offers the chance of reciprocity. It cannot be a testbed for later contact, for eventual conversation. It is not even, strictly speaking, an investment in future readers. The one-way journey into the void is a deliberate creation of an archive that will be orphaned by the physical dissolution of the very frames that make interpretation possible. That is the first shock to face. A society that chose elsewhere, in a nearer epoch, to scatter testimony across systems had plausible hope, scatter widely, increase the odds that some packet survives the churn of geology and cosmic vicissitude, and perhaps one day be read by a mind that shares enough of a semantic horizon to reconstruct context. But when the time scale of the cosmos reaches regimes where chemistry dies, where electrons find no stable comfort, where the notion of a robust, energy-harvesting biosphere is a historical footnote, that probabilistic hope collapses into a different calculus. Survival of matter does not equal survival of meaning. The second shock is thermodynamic. Energy, always the currency of work and life, is spent more thinly with each cosmic heartbeat. Stars have long since winked out in the nearby neighborhoods. Even black holes have drawn deep upon their stores. The available free energy, the kind that organisms and machines need to maintain ordered states and to perform computation, dwindles toward zero. Engines that once pushed ships and raised radiators become astronomically costly to run. The ship that persists in this epoch must either have prepared an economy of energy so extraordinary as to be nearly metaphysical, or accept that the labor of maintaining complex processes will yield to entropic lack. From the human vantage that framed earlier parts of this account, the technological options read like a catalogue of diminishing returns. Store information in conventional matter and it will be subject to decay. Bury it in black hole microstates and it may be returned only as Hawking radiation on timescales far longer than the lives of any conceivable interpreter, and code it into the fabric of space-time itself, and one confronts the enormous unknowns of quantum gravity. Each route offers speculation rather than guarantee. The fewer certainties left, the more the act of sending an archive becomes an ethical performance rather than a pragmatic investment. Thus the third reality asserts itself. The one-way voyage becomes a ritual of witness rather than a project of transmission. Once the prospective return is erased by physics, the meaning of the act shifts from audience to conscience. The dispatch of a record into the absolute dark is less about being read and more about refusing silence. It is an admission that existence once noticed itself. A species that can compose, weigh, and decide to send a last testament is making a final moral statement about being. Whether any future mind ever reconstructs it is secondary to the fact that the deposit was made with deliberation and honesty. The psychological weight of that admission is enormous. Where previous strategy recommended distribution and redundancy, pragmatic mitigation against geology and time, the new contour of choice demands a different kind of integrity. If an archive will be forever orphaned, it ought to be crafted to say what matters most to the originators. An unvarnished ledger of facts, an honest record of failure and success, an embodied claim about values rather than a propagandistic triumphalism. The ethical clarity required for such an undertaking is severe because there will be no reply, no interlocutor on whom to rely for correction or contextualization. The depositors choose not merely what to preserve, but what they would most want in the absolute quiet of an inaccessible future to be known about them. There is also an engineering humility to be embraced. In earlier parts of this narrative, an outward project was imagined as a form of stitching, a needle-pulling thread across the vast fabric of the galaxy. In this final stage, the image shifts. The last stitch is placed knowingly into a fabric that will fray. The thread is not meant to hold the garment together, but to leave a visible seam. Practical materials are selected for their ability to resist the kinds of encounters expected in far epic, high-melting, radiation-air-resistant ceramics, encoded lattices that can be reconstructed from spectral signatures even. After gross chemical change, isotopic patterns whose half-lives provide clocks that can be read from nuclear residues. A sophisticated archive in the void will prefer forms that do not rely on chemical or crystalline stability alone, but exploit redundancies across physical regimes, information represented in angular momentum distributions, in gravitationally bound geometry, in persistent topological invariance. Even these measures confront their limits. Quantum tunneling and the slow unleashing of decay processes threaten arbitrarily long-lived structures. Fundamental particles themselves are subject to the unpredictable asymptotics of speculative physics. The finality of the mission therefore includes a practical acceptance. Anything sent will change form, perhaps completely. The archivist must ask whether the transformation of a message into another physical modality is a failure or a new mode of life. When a ceramic tablet unravels into a diffuse radio background or a black hole disperses an imprint across Hawking quanta, does the original testimony survive as content, or is it merely scattered residue that cannot be reassembled? Philosophy and cosmic humility intersect here. The One-Way Project asks a civilization to decide on behalf of its descendants whether presence itself is a sufficient reason for making an imprint. Is the moral weight of having existed, of having loved, built, erred, and learned adequate to commit scarce resources to an act that will never be reciprocated? For some, the answer will be yes. The archive is a duty to originary consciousness, an act of bearing witness to a set of lives that once thrummed with intention. For others, the cost will be prohibitive. Resources expended on final testimonies are resources not spent on prolonging the vibrancy of life within the remaining habitable domains. That division is not merely theoretical. The choice has political consequences across scales. A society that decides to mount a final one-way dispersal must reconcile competing obligations to the living communities who endure in the dwindling epochs, to the biological systems that remain dependent upon repair and stewardship, and to the moral project of leaving a testament. The interplay of these obligations demands institutions capable of long-range accounting, of democratic consent that can meaningfully weigh present needs against gestures to a radically inaccessible future. Such institutions are rare and must be consciously cultivated. They are not inevitable corollaries of technological mastery. In the absence of unambiguous consensus, the act of sending a one-way archive becomes a cultural mirror. The content of what is sent and the manner of sending it reveals the civilization's self-understanding. Those who prioritize truth over triumph will embed failures as openly as successes. Those who value humility will invest in self-aid teaching encodings rather than imposing ritualistic symbolism. Those who cannot accept finality may attempt grand illusions, vast monuments of encoded music and art intended to broadcast identity, but the universe's long arithmetic will likely reduce them to noise. There is another, subtler layer of reflection, the aesthetics of the void. The cosmos at 10 net 41 years is not merely empty. It possesses a distinctive lightness and a kind of austere beauty. The last embers are faint, the background radiation reddened and cold, and black holes, still vast reservoirs of gravitation, are the last sites of concentrated structure. To dispatch a record into this landscape is to accept its aesthetic, a silence so profound that a small, deliberate mark seems both poignant and fragile. The act is not defiant in a boisterous sense, but elegiac. It is an aesthetic of farewell, quiet, exacting, composed with care. Contemplation of such quiet gives rise to a final ethical modesty. Human language has a habit of wanting agency to have cosmic consequence. The science of dispersion confronts that vanity. It teaches that to matter is not always to be preserved, and that to leave a record is not necessarily to make that record legible. The one-way archive is thus a moral rehearsal, a practice in humility that recognizes limitations while still insisting on responsibility. It is an act that binds the present to the future, not in the promise of an answer, but in the fidelity of testimony. There are, finally, metaphysical temptations that must be resisted. It is alluring to imagine mechanisms that cheat the cosmic ledger, consciousness emulations riding on exotic quantum substrates, information encoded in stable topological phases, immune to decay, or messages folded into the quantum entanglement of the vacuum itself. These are fascinating ideas and worthy objects of rigorous inquiry, But the ethos of this final stage demands restraint. Bold speculation must not displace honest accounting. A responsible archive prefers designs that are, so far as physics permits, intelligible and redundantly realized across known regimes, rather than betting the last of planetary wealth on speculative invariance. So what, in the last account, does it mean to choose the one-way journey into the void? It means accepting an irreversible separation from the social, biological, and material context that made meaning possible. It means converting action into testimony when reciprocity is precluded. It means choosing the form of the last statement, what will be said when no reply can arrive. It requires institutions capable of sober reflection and ethical restraint. It requires scientific humility about the limits of material persistence and moral clarity about the values a species is willing to inscribe into the dying universe. In that way, the one-way voyage is not, finally, an act of futility, but a form of ethical expression. The universe, in its long arithmetic, offers no guarantees, but the deliberateness of a goodbye, when crafted with honesty, redundancy, and pedagogical care, confers a dignity upon the act of being. Even if the message is never read, the making of it is itself a testimony that at least once a thinking species took the measure of its own finite light and chose, in clear eyes, to place a careful record into the dark. That choice, neither arrogant nor naive, neither triumphalist nor resigned, becomes the moral content of the last stitch. It is a quiet, defiant assertion that the act of remembering matters even when remembrance can no longer be answered. If, in the end, all things are erased by time's patient mathematics, does the work of exploration still carry meaning? That is the question that closes the ledger and opens the last quiet paragraph of this long account. It is a thought that, like a small stone dropped into a very deep well, sets off concentric waves, ethical ripples about responsibility, epistemic ripples about what can be known and preserved, and existential ripples about why a fleeting intelligence persists in the face of inevitable dissolution. The answer that emerges is not a tidy declaration, but a layered argument, one that rests on the nature of meaning itself and on a species' decision to respond to the cosmos not with defiance, but with deliberate care. Meaning, in this register, cannot be predicated solely on survival. If permanence were the sole criterion of worth, then the cosmic ledger would be merciless and all acts ephemeral. Instead, meaning accrues in practices, in the way a civilization chooses to form questions, to record answers, to distribute testimony, and to balance curiosity with stewardship. Exploration, considered as a collection of these practices, functions as both discovery and discipline. It discovers new landscapes, new constraints, and new forms of possibility. It disciplines institutions and cultures to plan beyond the pulse of electoral cycles, to design artifacts to outlast routine weather, and to face moral trade-offs with sustained deliberation. The long view reframes exploration. It is not merely a quest for objects out there, but a training of the civic muscle to care across time. The human inclination to reach outward is old and simple. Curiosity, the wish to know what lies beyond the horizon, the urge to see more than one's immediate world. That urge did not begin with starships. It is woven through early migrations, the mapping of coasts, and the slow indexing of seasons. What changes in a cosmos that counts years by billions is the scale of consequences. The same impulse that once shaped fishing vessels and caravans now prompts designs for continuous 1-gig carriers, for beamed propulsion arrays, and for networks of durable deposits scattered across stellar neighborhoods. The technologies and strategies are vastly different, but the psychological and moral texture is continuous. Exploration is an expression of a species that prefers to learn and to risk rather than to settle into parochial quiet. Yet the motivations for exploration are not reducible to curiosity alone. There is also an ethical logic embedded in the desire to preserve testimony. Faced with the geological appetite that erases cities and the cosmological winds that redshift signals into silence, a civilization can respond in two principal ways: by pouring its efforts into making the home better in the present, or by investing some of its capacities into sending durable witnesses outward. The two paths are not mutually exclusive, but they are in tension when resources are scarce. The documentary record of deliberations across councils and laboratories, as recounted earlier, shows that societies often attempt both. They repair coasts and restore ecosystems while designing archives, ceramics baked to high temperatures, isotopic anchors, nested self-teaching keys to be embedded into the dark. The moral calculus is constant: how to ensure that present flourishing does not get traded away for speculative future audiences, and how to accept that some acts of testimony may be as much about the present as about the future. In assessing meaning, one must account for the variety of outcomes that exploration might produce. There is the optimistic possibility that a distributed program of archival deposition, coupled with deliberate pedagogical design, results in legible traces found by future intelligences, descendants of the species, or entirely different minds. In such a scenario, the act of sending is vindicated by the comprehension of another mind. But comprehension is not necessary for meaning to exist, even if none of the outward messages is ever decoded. The act of composing and dispatching them shapes the society that makes the choice. It fosters disciplines of honesty, encourages cross-disciplinary collaboration, and demands a candid account of failures and achievements. The process itself is formative. The making of an honest archive is an ethical exercise, choosing humility over propaganda, redundancy over show, pedagogical clarity over rhetorical flourish. In that sense, exploration's meaning is embedded in character formation as much as in eventual readership. There is also a different mode of meaning that exploration can produce, the intimate work of being present in a vast universe. The discipline of patient instrumentation, building arrays that stand watch, calibrating senses to listen for faint signatures, reading spectra as if they were old letters, instills a form of humility. To listen rather than to conquer becomes a moral stance. That stance reframes success. It is not merely planting flags, but cultivating attentive patience, preserving the ability to ask better questions, and resisting the temptation to treat the cosmos as merely a resource. From the perspective of deep time, the practice of careful observation and of modest, well-documented action is itself a kind of dignity. The account of physical constraints, the invisible prisons of distance, radiation, and time, matters because it anchors meaning in reality. The long arithmetic of the Lorentz factor, the erosive appetite of plate tectonics, the receding of galaxies beyond the Q boundary, and the potential endgame in a proton decay epic are not rhetorical devices. They are the terms in which a civilization must negotiate its desiderata. People who imagine exploration as pure celebration sometimes downplay these constraints, but the documentary record shows that confrontation with limits refines intent. Knowing what cannot be done helps to determine what should be done. The ethical muscle thus pumped by constraint is not a defeat. It is a kind of moral amplification. It forces cultures to choose more carefully what to say to whom and why. That moral amplification is evident in the choices about what to preserve. The greater the awareness of time's appetite, the stronger the tendency to favor honesty. If a deposit might be orphaned beyond causal reach, the argument runs, it should not be a propagandistic flourish. It should be a candid ledger, an accountable triumph and error, of ecological footprints and of ethical choices, of music and mathematics and the hard ledger of missteps. The documents of deliberation frequently return to this point. An archive that lies forever in the dark will speak on behalf of its creators, therefore it should speak truthfully. The act of constructing such a testament becomes an exercise in moral courage. Exploration also reconfigures value by shifting emphasis from permanence to legibility. The earlier parts of this account argued that survival is not enough, meaning requires that survivors be able to reconstruct context. As a result, hardy archives are paired with self-teaching scaffolds, prime numbers, spectral constants, isotopic clocks that can be measured without cultural priors. This technical pedagogy is part of a broader ethical pedagogy. The humility to assume that future readers will lack shared languages and the generosity to design messages that begin from universal facts. Creating such pedagogical layers is an act of empathy that stretches across eras. It is a practical instantiation of care. The question of home, of whether more meaning is derived from repairing Earth or from sending testimony outward, recurs through every moral ledger. The documentary voice insists on a synthesis. To ride into the long night is not an excuse for neglecting the immediate world. Indeed, a culture that invests heavily in outward testimony while ignoring the biosphere risks undermining the very moral foundation that justifies its messages. The ethics of exploration therefore demands parallel commitments, stewardship at home and disciplined ambition abroad. That is the most decisive moral lesson of the practical experiments recounted across this account. Exploration is meaningful when it is paired with responsibility. Why, then, persist in exploration when the universe's long arc concludes with dissolution? The answer returns to human finitude and to the character formed in meeting it. The awareness of eventual erasure does not cancel the value of making considered choices in the present. The act of composing a careful record, of choosing to send truthful testimony, of refining technologies that protect life and preserve knowledge. These are moral acts that confer value irrespective of guaranteed reception. They are practices of fidelity, fidelity to reason, to honesty, and to the conviction that a species can be judged by the candor and generosity of the legacy it attempts to leave. The moral image that best fits this final posture is not a monument that defies decay, but a seam sewn with intention. The needle does not hold the whole fabric together. It marks that someone cared enough to stitch a pattern, to leave a set of coordinates for narratives that might never be read. To sew is to accept fragility and to act regardless. That act is small on the scale of cosmological time, but morally significant within human scales because it answers anxiety with deliberation rather than despair. There is also an argument about identity embedded in the decision to explore. To restrict a society's identity to the survival of a narrow lineage is to diminish the richness of what that society has produced: stories, art, questions, and scientific insights. Exploration allows a civilization to externalize its self-understanding across a broader theater. The aim is not to secure immortality for individuals, but to practice a kind of generosity, giving the future access to a considered record so that the species' presence might be recognized by whatever minds come later. If that generosity is sincere, it becomes an ethical emblem, an acknowledgement that beings can act on behalf of those who cannot vote for or resist those actions in the future. Of course, there are risks of hubris. The urge to broadcast identity into the cosmos can become a moral excuse for neglect. The documentary record is frank about this pitfall. It describes debates where the seduction of grand, irreversible dispersals had to be weighed against the pressing needs of living communities, where the resources demanded by beam propulsion or extensive archival programs could be spent on climate repair, biodiversity restoration, or social safety nets. The responsible strand in those conversations insisted on balance. Outward projects should not substitute for inward care. Meaningful exploration is sustainable exploration. Finally, the emotional register of the enterprise matters. The feelings that surround these projects are complex: wonder, anxiety, grief, pride, humility. Those feelings shape the choices that engineers and ethicists make. Wonder motivates the invention of propulsion and the calibration of instruments. Anxiety sharpens the prudence of redundancy. Grief informs the insistence on honesty and archival composition. In sum, the effective life of a species is not merely ornamental, it is constitutive of ethically sound exploration. If the cosmos ultimately dissolves, exploration retains meaning because it is, at bottom, an expression of a moral temperament. It is an enactment of curiosity balanced with care, of courage tempered by humility, and of boldness shaped by honesty. To explore is to refuse parochial complacency and to commit to a discipline of witness. The act of sending a truthful, well-designed record into the dark is simultaneously an admission of limits and a choice to testify nonetheless. It is a form of practical piety toward the fact of consciousness, a way of saying, with care rather than vanity, that existence noticed itself and chose deliberately to leave a trace. Thus, the final score is not a binary verdict. If everything dissolves, exploration does not lose meaning. It changes the kind of meaning it carries. The value shifts from guaranteed transmission to the integrity of the act. The last witness may speak into a void, but the decision to speak truthfully, to design for legibility, and to balance outward ambition with the duty to hone renders the act meaningful in a moral sense. Exploration becomes an ethical discipline, a practice of asking, of making, of choosing. It remains, even in the face of dissolution, an art of bearing witness. The concluding image is modest, not a triumphant flame lighting a dark cosmos, but the careful placement of a small object, a layered, redundant tablet, or a packet of encoded light into the silence. It is sealed with a set of keys that begin with universal mathematics and, if fortune permits, end with music and a truthful account of a species that loved, erred, and thought about its place in time. That small act, performed with deliberation and humility, is the definitive answer to the question posed at the beginning of this account. The cosmos may be patient and indifferent, but that indifference does not nullify the moral significance of choosing to know, to remember honestly, and to reach outward with care. In the quiet arithmetic of the universe, to have acted with such intentionality is itself a form of meaning, fragile, finite, and profoundly human.